Today we have just a few minutes to think about stuff. I want you to have some focused concentration for 45 minutes. I'll be moving a little bit faster, small, so that I can finish up. Okay. Every Saturday is one topic. No question. I know your notes. Now they are bringing. You are supposed to actually finish rate of chemical reactions and submit it by next week Saturday. When we'll do one physics topic also. Okay, I'll revise more concepts 1 and 2 with you. Revise of 1 and 2, empirical formula, molecular formula, those things. We'll solve more on it, so you can get more detailed understanding. I think when we have structured information, you guys will do well, and you have a reason to learn. When I motivate you, you have something to study, so to get you on your toes to work hard. Now listen carefully. When we talk about rates of chemical reaction, we are saying that for every chemical reaction that occurs, reactants are consumed and products are formed. For every chemical reaction that occurs, reactants are consumed and products are formed. When you say that, you can give me a practical example even in the house. When you are making a brine or sugar solution, you pick up the granular sugar or granulated ones, or you can see the sugar is a little bit solid, tiny solid, tiny stuff. Then you dissolve it into the water. What happens is that a new solution is formed, but the sugar gets lost. It's got consumed to form a new solution. In that regard, there are several kind of reactions that goes on in this world, that the reactant that comes up collide together. The particles of the reactant to collide together so that they can form something new. And that is all what we are going to speak about this time. That's what we are going to speak about this time. Please, I'm coming, Spain. So we find out that, can you buy me? So what happened is, I'm so sorry. Okay. So what happened is that we are trying to look at the way certain reactants will come together so that they'll be consumed, and then we can form products. You get me? So what is rate of chemical reaction? Rate of chemical reaction is the amount of reactant consumed per unit time, or is the amount of product formed per unit time. So you can combine those two sentences together and say rate of chemical reaction is the amount of reactant consumed per unit time, or the amount of product consumed per unit product formed per unit time. We can finally also say that it is the change in concentration of a substance, that is a reactant and product, with time. The concentration of the sugar I dissolved in the water will reduce until it changes into the concentration of the brine. So you find out that the concentration of sugar will be lost. So that's why we say the thing is being consumed per time. As time moves, the concentration decreases for the reactants. But as times move, the concentration increases for the product, because the reactants are dissolving to form the product. So, final statement on the definition. What are we thinking about today? You are thinking about how chemical reactions occur, in a sense that for a chemical reaction to occur, substances called reactants will come together to be consumed, so that they will form new substance that will be called the product. And then these reactants, as their concentration change per unit time, that's what we consider as rate. Their concentration, as their concentration change per unit time, that's what we consider as rate. Or as the reactants are consumed and the products are formed per unit time, that's what we say rate of chemical reaction. I need someone to explain something of what I said. Tell me what you heard. Tell me what you understand, and let me move on. Every time I finish teaching a particular concept, someone needs to expound on it. Give me what they've heard, idea on it, then we move on. So, Yanko Hanebwa. Kojo, please, let's go. Kojo.
The rate of chemical reaction, it deals with the relationship between the reactants and the product. So we know that in a chemical reaction, we know that in a chemical reaction, the amount of reactants, there is like a chemical relation with the reactant and the product. And then they say the rate of chemical reaction is the amount of reactant consumed per unit time. Now, when we get a chemical reaction, you know that the reactants will get consumed to form a product. So here we get our two basic definitions, where we see the rate of reaction is the amount of product formed per unit time, or the rate of action, the rate of reaction of amount, the rate of reaction, the amount of reactants consumed per unit time. So you see that the reactants are being consumed to form the product, or the products are formed from the reactants consumed. And now for the third definition, you said the rate is the change in the concentration of a substance with time. Now we know that concentration deals with, as in mole per dm cube, as in the number of moles in 1 dm cube of solution. So once the reaction goes on, we know that the concentration also decreases, because in some reactions there's evaporation. And this includes 3 definitions of rate of chemical reaction.
Thank you. Very good. Very good. So I'm asking a question. 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 So for a chemical reaction, which entity of a chemical reaction or chemical equation decreases in concentration, and which entity of a chemical reaction increase in concentration? So which one will decrease in a chemical reaction? Which one will increase in terms of concentration? Continue. Let's go. Yvonne.
Okay, so according to what I heard and what you are saying, the reactants are the one which are consumed in order to form the product. So I think the reactants will decrease and the products will increase, since the reactants are being consumed to form the product. Thank you.
I love that. That's good. That's correct. So now we have finished this idea. Everyone understands it. Now listen, we are going to mathematically show how chemical equation reaction occurs. We are going to show it. We are going to show it. Now, expression to show rates. Listen. So let us all consider a particular reaction where A maps to B. We all established that A is the reactant. It means that it is consumed during the reaction. And we've all established that B is the product. It means that it is formed during the reaction. Now look at how we mathematically express rate. Rate in terms of, I'll teach you math. I'll teach you rate in math before you go to school. But look at how we mathematically express rate. Rate of disappearance of A. Of course, A will disappear. The person is consumed. What do you expect? It will disappear. It wouldn't show up again. It will tear down. It will break down. It will decompose. It will disintegrate. It will destroy to come and form the product. Now, the rate of disappearance of A will now become dA over dt. The dA is the dA of the concentration of A, please. Concentration of A. So dA of concentration of A over dt. I'm using this parenthesis to show that it's concentration. So over dt. When I find the differential of the concentration, I'll be able to find the rate. You know, rate is with time. So when we find that of dt, we find time. I've not taught you application of differentiation. This wouldn't have been a problem, but I'll teach you that this time. I've already finished the better part of differentiation, so I have to do the application. I'm done. So rate of disappearance of A is now written as R is equal to D of A. That's the A inside. There's a concentration over the T. The negative sign signifies that the reactant is consumed. The negative sign signifies that the reactant is consumed. Now, the negative sign indicates that the concentration of the reactant is decreasing or consumed as the reaction proceeds. The negative sign, it only shows that. Now, rate of appearance of B. So look at the chemical equation, and B appears. So the concentration of B over dt, R is equal to plus dB over dt. The plus, that's the positive sign, shows that the concentration of the product are increasing as the reaction proceeds. Concentration of the product are increasing as the reaction proceeds. Now listen carefully to the last section I have to explain to you. This time I've refined how I teach. I'm going to do over and over and over and over so that you understand. For every example, I'll show you the similarity of every single example there so that you can solidify your understanding. Hence, all rates are equal in magnitude. Take note in your mind. All rates are equal in magnitude. Every rate is equal in magnitude. So minus d of A over dt, or the rate of A, is equal to the rate of B. The rate of A is equal to the rate of B. Okay, so now you see, this means the reaction occurs at the same overall rate, even though the reactants decrease and the product increase as the reaction continue in terms of concentration. Even though the reactants decrease and the product increase, it means that the overall rate is equal. The rate at which reactants are decreasing or destroying or consumed is equal to the rate at which the product is formed. It can't happen any other way. Look at a seesaw. When someone sits up, the other one comes down. That kind of balance is what is happening here. The rate is still the same. If a twin the other guys go and sit on the seesaw, you know how it will throw up the next person at the other side. That kind of rate is the same kind of the energy you put in the same way you see at the other side. So we equate all rate. We equate all rate like that. The all rate is equal to. So I'm explaining for the last time, and someone does it, and we move on. I'll post this on the file once I'm done teaching. So listen, every topic I've highlighted on the platform, I'll try to finish them, but I'll create the note. I'll teach it to see that there is no mistake in it. Then I'll post it there. Then you go and reference and use it to create your own note. So when I'm done, I'm putting it there. You have up to Saturday, next week Saturday, to create your own note, because next week Saturday I'm teaching something else in physics. I think I should teach you atomic, like very well, so that it'll be very cool. Or depends, I'll see. So take note of that, please. Topic macho so when I learn with you, I find out there is no mistake in there, then I post it there, then use it. So all of you, I'm doing it with you because we want to spot certain things, word mistakes and all that. So check that as we move along. So consider the reaction A maps to B. A is a reactant, B is a product. Rate of disappearance of A disappears. You see the rate D of A in terms of concentration over dt. One can concentration can concentration on who's a rate na we are saying it in terms of concentration. Can negative sign and so can negative sign to show that the concentration of the reactant is decreasing. Okay, the product to we add the positive sign, but I don't need to write it, add it if I'm solving my work. I just bring it so that you guys will see as a first example what I say, so that you see that there's a positive sign there. In my consequence examples, I will not put positive sign there. I'm just putting for you that you can see it well. So the rate of disappearance of B, because it is formed, is positive, and the positive sign shows that the concentration of the product are increasing as the reaction proceeds. Hence, all the rates are equal in magnitude. What is hence? Note that all the rates are equal in magnitude. That is the A over the T. That is the rate of A, and the B over the T in terms of concentration. That's the rate of B. Is the same. And I've done a small little explanation here. Someone should explain. Let's move on. A female should explain. A guy explained the first one, so a female should explain. Let's move on. Explain this example and let's move on. Hey, the girls there, when I call you, the what you do there. The boys, when I say boys, then Jeff, Alex, and Kojo will raise up their hands. When I say girls, then Loretta will raise up her hand. But you guys too know the thing. I've told you, let us collaborate. Like feel free and talk. Use this as a platform to build the way your communication skills. You get it? They can't move me. Yo, Loretta, let's go.
Okay, so we mentioned that rate of the chemical reactions, the amount of reactants consumed per unit time. So when we take A as a reactant, it means it's consumed become the B during the reaction. So the rate of disappearance of A, that's like the rate at which A is being consumed gets B. We have it's given by the formula R is equal to minus the A over the T, and the A in the brackets there means concentration of the reactant in the reaction over the T, that's the unit time, and it's minus because the reactant is decreasing whilst it's being consumed. And then the rate of appearance of B, that's while A is consumed, we get the B to be our product, and it increases. So we have the positive sign there. Yeah. This is what I can say.
Thank you so much. Now talk about this last part. All magnitude as thing. Talk about it.
And we also mentioned that all the rates are equal in magnitude because the rate at which A is consumed, that's the same like rate at which B comes about or it appears.
Thank you so much. Great. That's guy. You are good. Now look at this. Let's go to another example. This one, a boy will explain. In the the explanation I'm giving you. Use all your heart to listen to what we are doing here. Rate and sign next week about. We are putting rates in the bin. It's not a topic in chemistry you should worry. A topic in chemistry you should worrying is those more concept stuff because you need it for your 50 marks in practicals. Look guys, in your last sections, I'll be teaching you practicals, how to do these titrations and stuff. And you have to be very good with it. Expressing rates, reaction rate using unitary mole ratios. What about equations where there are mole ratios in front of them? Like the first one we solved, the mole ratio was 1. All of these guys too, mole ratio is 1. You don't know mole ratio. Say number na a war reactant ni product no omonim no. And then a ratio, mole ratio. Then your friend is stoichiometry ratio. And on number na way nim no dina homa moles of that particular reactant and our moles. Note that all the rate can be equated. Did you just see? We say all the magnitude of the rate are equal. So it means that minus d over dt is equal to minus db over dt is equal to dc over dt is equal to dd over dt. Why is Gideon Hammond crying? Why the crying emoji? Why crying? I don't know. Oh how ni say na usi wamani ni say Now we see more sir. I can see that most of you are laughing. Osun to my relax kakana. Mention the into Osun and to class na koyi I like it. My network is not. I'm not hearing anything say. It's breaking. Oh, don't worry, Gideon. I'm going to put it on the side. This time I said I'm not going to make anyone miss anything. It's sad, but I'll put it on the side for you. All the recording, just purely like this. I'll take just this one and put it there. Simple. I won't go and stress myself. I just have to make sure that you guys get it and watch it. Okay. Inti, Israel, hey, Gideon, means so. Why? 300 men to conquer battles. You can use your small time to conquer the whole chemistry. Don't worry. All right. What you say? Now this means the reaction proceeds at the same overall rate, even though the reactant decrease and the product increase as the reaction continues. So let me do another final explanation. When all coefficients in a balanced chemical equations are unitary, there is no need to divide by the moles. If we are dividing by the moles because you can't have plenty moles, we need the standard mole 1 to compare rate. So when something comes up, but say a 1 there, it will compare, will be fine. That's why we are saying that when the balanced chemical equation, all the moles are unitary, or when the coefficients are unitary, we have to just go on further and compare. You get it? In that case. Now know how to write rate, okay? Rate of the A, you see, I brought my negative sign. Rate of the B, I brought my negative sign. And then the C2, I don't bring negatives. When I finish, I equate all of them. All of them, saying that all of them have the same rate in terms of magnitude. Now, a boy should explain and let's go on. A boy should explain and let's go on. A boy should explain and let's go on. Rate of the B. Bars, bro. Let's continue. Who is explaining? One guy should explain. One guy should explain. Hey, boys. Then let me close the class. After all this noise, it shouldn't be always one people. Please, Charlie, raise up your hands, boys. I want to see a lot of hands, at least 5. If I don't see 5 hands raised, I'll stop this class from the boys because Mugumeni Masipa. Say me knew to say so would beat me explaining Nama with check class. Only 2 people have raised their hand. That means the boys are not so the boys, why are they here in the first place? Like, why are you joining the class in the first place if you are not listening to know how to explain? Why are you doing that? Jeff, please explain and let's move on. I know what to do.
Okay. So, expressing reaction rates using unitary mole ratios. To consider the reaction A plus B going into C plus D. The stoichiometric coefficient is the number that's attached to all the reactants in the product. So for the A, the number attached to which is B, 1. And for the B, the number attached is 1. For C1 and for D1. That's the stoichiometric coefficient. Process 1, we don't write it. And when all the coefficients in a balanced chemical equations are unity, which is 1, the rate of the consumption information, except is the rate of the consumption information of substances can be directly compared. In this case, each rate is technically divided by 1, but since dividing by 1 does not change the value, there is no need for further scaling. Yes, so all they are trying to say that is that if all the reactants in product have a stoichiometric coefficient of 1, the rate of the reactant, which is negative, let's say for A, for example, negative A over dt. If it were the coefficient were to be 2 or 3 or more than 1, you would have divided by the coefficient because it's a 1 move. But since it is having a stoichiometric coefficient of 1, you write that negative dA over dt divided by 1, but since you divided by 1, you don't write it. And you can equate all of them. So the rate of disappearance of any one of the reactants can be equal to the rate of production of any of the products. So equating it, you can get negative dA over dt
equals negative BB over DT. It's also equal to BB over DT, which is also equal to BC over DT. That's all we are trying to say here.
Thank you, Jeff. Exactly. Everything shows. Everything is clear. Everything is clear. Now, we might not only get the opportunity to relate only monetary unitary stoichiometric coefficients. Sometimes we would get some stoichiometric coefficients that aren't unitary. So relating reaction rates to stoichiometric coefficients which are not unitary. When expressing the rate, I need the female to read this for me, please. I need a female. Era Princess, please read. Era Kenkanenko.
Relating reaction rates to. Sorry, I'm coming.
So you were in the kitchen and you were cooking and you were listening to chemistry class. Hey, let me call another person. Wait, relax. Continue cooking in the kitchen. Wait, let me call someone else. Hebsy.
Relating reaction rates to stoichiometric coefficients. When expressing the rate of a reaction, the coefficients in the balanced chemical equation are used to relate the rate of consumption of reactants and the formation of products. 2A plus 3B maps to 5C plus CD. 6D. A and B are the reactants. That is, they are consumed during the reaction. And C and D are the products. That is, they are formed during the reaction. To compare the rate of change of each substance, divide the rate of change of concentration by its respective stoichiometric coefficients.
Thank you. Like that. We need 1 mole. 2 moles of A, 3 moles of B, 5 moles of C, 6 moles of D. But that is a balanced chemical equation too. But we next need one each. And now so that we can compare them according to rate. Come on. How do we get it off? And when you need one thing and you are playing, don't you divide? In moles, remember Avogadro. When we need 1 mole of a substance and the particles are plenty, what do? Don't we divide by 6.02 times 10 power 23? Yes, because we just need 1. So we divide to get the unitary thing that we need. So let's go on. So the rate of reactant, you find out that the rate of reactant of A I have to write it like this, but because 2 is informed, I need to clear the 2 off. So I now divide by 2. When I divide by 2, reciprocation method make it half. Then I bring the half in front. It means that half of A is what I need to be unitary. Of course, now we say half. Yes, sir. So now half of the rate of A is what makes the real rate of A that we need. How did we do it? We divided by 2. Simple. What it means is that when you find any stoichiometric coefficient that is not unitary and it is in real number form like 2, 3, 5, 6 like that and not in fraction, make sure you just divide by it. Some people just keep it in their mind that, okay, I don't need to care about it dividing or not, that they will say, let me do it 1 over the number. But I don't like it. I need you to understand the detail part of the work. For the rate of B also, I'll divide by 3 to get the 3 rid of it. So it become 1/3 of the B. So 1/3 of the B is 1, is the one that we need. We don't need 3, we need 1. So 1/3 of it is what we need. Please, in terms of 1, bias, equal stuff. What does the negative sign indicate? It indicates that the concentration and reactions are decreasing as reaction what proceeds. Now rate of product. That 1 to 5 and 6 for C and D. So we do the same thing, and then we do the reciprocity of it. It becomes 1 over 5 of it and 1 over 6 of it. So the positive sign shows that the concentration of the product are increasing as the reaction proceeds. Now we can now equate all of them. showing us that all the rates are equal in magnitude when properly expressed in their coefficients. Properly expressed in their coefficients. Men ko confa obi a ye compare 1. O de o ko fa ba and wako compare 3, 4, 5. Dabi. We are biased. We are wrong. Compare 1 my so 2 or higher and half. Say 3 or higher and 1/3. Say 4 or higher 1/4. You pay 1 pair. Say 7 or higher 1/7 because you pay 1 pair. This mole means the reaction proceed at the same overall rate, even though the reactant decrease and the product increase as the reaction continues. So, a girl to explain, let's move on. Oh, let me call them. Millie, explain it.
Okay, so please, relating reaction rates to stoichiometric coefficient. So assuming you are given a reactant and a product, 2A plus 3B maps to 5C plus 6D. We all know that the 2A and the 3B are the reactants, which means they are consumed during the reaction, and the 5C and the plus 6D are the product, which means they are formed during the reaction. So in order to compare this reactant and product, we find their rates. So finding the rate of A, which means the A is in terms of concentration. So it's given as R is equal to neg dA over dt. And we know that it's having a coefficient of 2, but we want all of them to be we want all their coefficients to be in 1. So therefore we divide neg dA over dt divided by 2, and we get R is equal to minus dA over dt times how, because division it reciprocates to become multiplication. So times 1/2, then we bring the 1/2 in front, making it R is equal to minus 1/2 dA over dt. And we move on to the next one, which is rate of reactant of B. And we also know that the coefficient of B was 3. In order to make it 1, we divide it by 3. But then it's negative, so the R is equal to negative dB over dt divided by 3. And it reciprocates to become 1/3. And the 1/3 comes in front of the negative sign, making it R is equal to 1/3 dB, and the B is in terms of concentration over dt. And this means that the negative sign indicates that the concentration of the reactants are decreasing as the reaction proceeds. So we move on to the rate of product. So the rate of product of C, it was having a coefficient of 5. Since we want it to become 1, we divide it by 5. So the R will be equal to positive dC over dt, where the C is in terms of concentration, divided by 5. So the 5 reciprocates to become 1/5. So R is equal to dC over dt times 1/5 here. And the rate of product of D, the coefficient of D was 6. And in order for us to make it 1, we divide it by 6. So the R will be equal to dd over dt divided by 6, which reciprocates to become 1/6. So the R will be equal to dd over dt times 1/6. So therefore, the rate of product of C will be R is equal to 1/5 dC over dt. And the rate of product of D will be R is equal to 1/6 dd over dt. Yeah. So hence the positive sign shows that the concentrations of the product are increasing as the reaction proceeds. So we therefore equate we equate the reactant and the product. So all the rates are equal in magnitude when properly expressed with their coefficient. So therefore, because we want to equate, because now all of them are having their the same coefficient, we equate all of them together because all the rates are equal in magnitude. So therefore, R will be equal to minus half dA over dt is equal to minus 3 dB over dt is equal to 1/5 dC over dt is equal to 1/dd over 6 dt. So the ones in the brackets, they are all in terms of concentration. So this means the reaction proceeds at the same overall rate, even though the reactants decrease and the product increase as the reaction continues. Thank you.
That's my girl. Charlie. That is it. Perfect. You get it? Now let me add something small. You see the magnitude being the same and the rate all being equal. It means that I can equate it anyhow. Jeffrey expressed it in his explanation, but I forgot to also say that part. Mokasa na mama kai other part in so I'm the count. In the part I can equate, I can relate A with D, I can relate D with B, I can relate B with C, I can like C with A, I can like A with D, D with C. I can equate any two of them. I can equate any two of them. I can choose any two of them and equate them, and they'll be the same. What I say? Fashion trimsa. Then call next one. Relating reaction rate using fractional or scaled coefficients to express the rate of reaction for each substance when they are in their fractional. When the balanced chemical equation has fractional coefficients to express the rate of reaction of each substance in a balanced chemical equation equation with what? Scaled or no, with fractional coefficients, comma. Divide the rate of change of its concentration by its fractional stoichiometric coefficient. Divide the rate of change of its concentration by its fractional stoichiometric coefficient. So we are going to do the same things again. This is the fourth time we are doing repetitive stuff. The fourth time we are doing repetitive stuff. I'll check your note next week. By next week Saturday, this whole week, do chemistry, do rate of reaction for me while you revise your other things. Don't rush in chemistry. Revise it, all the things, electronic configuration, all the hybridization, all the chemical bonding. Revise everything. Now, so you find out that A and B are the reactants. That means that they are consumed during the reaction. And C and D are put that they are formed during the reaction. The cancer rate of reactant A is this. Rate of reactant B is also this. How is it that? Because it's half that's in front of it. Yes, so half. Yes, you pay one. Undru one. Into your base scaling number one. Your base scaling number one. Into your half. I am multiplied by 2. The sum you be 1. So much I say. He is scaling. We have to scale it. We have to scale it into a half. Your money being count. What I say? Or 1 over 3. Your money by 3. Or 1 over 4. Your money by 4. We have to scale it. We have to scale it to 1. We have to scale it to 1. You have to scale it to 1. Type. We have to scale it to 1. I just want you to type for me to see whether you are on here. Type it. Let me see. You have to scale it to 1. You have to scale it to 1. Stephanie, you have to scale it to 1. Kojo, Ella, Ebzy, Abiba, Pius, Winnie, Michael Osei, Safwa, Collins, Rex, Claudia, Lena, Jacqueline, Akusia, Millie, Bismarckedu, Augustine, Godfred, Amon, Frederick, Priscilla Magala. Good. Where's your brother? I've not seen him yet. John, Annie, Mishira Pukwa Befi, Diane. Good. Elom, Letitia. Okay, Letitia is a good. Letitia, take attendance for the science students for me. Prince is here also. Okay, good. Great. And Timonamwa. That's good. We have to scale it to 1. Great. So now listen, you scale it to 1 by dividing it by half. When you divide by half, it brings it back. It means that we multiply by 2 so that the thing becomes better, like a very real thing. What you say? Let us go to the product. Product necessarily 1 over 4, we scale it. 1 over 5, we scale it, but we don't add negative. Okay, we make it positive because they are formed. What you say? Letitia is here. Jeffrey too is here. Vinny Abuaje. Vinny is the only new guy that I know has joined class all the time. Vinny, on open joining class. Let's continue. So you see, C and D has been now well performed. C and D has now been well performed. The positive sign shows that the concentration of the product are increasing as the reactions also proceeds. What you say? Now, you know, at the final stage, we equate everybody, meaning that you can relate any two of the reactions or reactant or product. Okay, now we have done. We are done. Now, yanko examples, like yanko proper examples. Now, if you examples, now, if you yamfa agroni na emba ni for this house. So you find out that consider the following chemical reaction. Look at the chemical reaction. Nitrogen pentoxide. Nitrogen pentoxide and it's being decomposed into these two parts. And then this one, they are numbers. And then nitrogen and hydrogen for ammonia. Now, this one, is that write down all the rate of reaction for each of the reactant and product. Write down all the rate of reaction for each of the reactant and product. What do you think it will be? Just what you have been doing all over. Look at it. Dinitrogen pentoxide, that is reactant for that, will be D of that over dt. Bibia always say, but 2 on a name. One say 2 on a name. 2. So we have to divide what I say. 2 on a name. Or you mean, so your person will be 2. You say it divided by 2. So it should be half. Half of it. We need half of it. Okay, you see, I didn't add that. No. That means that I can make a politin for online. Entiana. Me say I was here answer my posting. I do a lot of things. If I was a teacher for my life day, I would have dedicated all the whole time for this. But I'm doing other things too, Charlie. So it's not easy. But I want you guys to also learn. But I can't say learn with my mouth without leading and learning. So I have to come and show you some things so you can also be motivated to learn. Sua bibia fa book ni she utrim na nante. Fa book no fa she utrim na nante. Bia hu a omunsuro. Don't be ordinary. Just don't be ordinary. Let something be different about you. When half, because we want to scale it. So the nitrogen pentoxide, we scale it. Then the NO, we also scale that one too. It was 4 in form there, so I need to do 1 over 4. You see, I didn't do it. Let me make it better. But that one, I don't do negative sign. Why don't I do negative sign? It is formed in that regard. Now, let's move. Rate of product. Look at the product. That one too. Let's see what there was nothing in it. It was unitary. So we take that one. You get it. Let's do this one too. 3 is in front for the A. That means we have to multiply by 1 over 3. Let's see a chain back out of 3. We don't want all the 3. So 1 all over 3. You see the mistakes I did? Good. Then the B, half. Into yepemienu. We want 2 of that. It is half. We want 2 of that. And then the C, also you say, we want half of that. Okay, I brought it. We want half of that, but let me make it nice. Half of that, but don't bring the negative sign for that one. We want half of that. Half of that. You guys understand the thing so far? I love the way you guys understand it. If you don't understand it, I would have felt it. You understand it, and I like that. Now let's move on. Look at this part 2. Nitrogen or a half. In Tibet times by saying 2. That one I did it right. 2 over 3. 2 over 3. So what do? We divide by 2 over 3. So it will swap. It becomes 3 over 2. Hope I try dividing and use a reciprocating method and see. It will swap like that. What I say? So we swap 3d8 over 2 over 2 dt like that. And then the last one, it was just unitary. Unitary means the same thing. Now you are done. You see? Yes. Do you guys understand up to this point? If you understand, say all clear. Say all clear. And let me move on. Okay. Say all clear. Let me move on. Rex, all clear. Irene Patipios, all clear. Stephanie, say please, all clear. Kojo, all clear. Michael, all clear. Godfred, all clear. Mikal, Samantha, Jeffrey, Diane, Elom, Lena, Ella, Ejapoma, Inshira, Hebsy, Alex, Besmakedu, Prince, a bit. Prince, why a bit? I've done the same, I've repeated the same things like 10 times. Because with every example, we find similarities there. And so you should see it. I'll post it, go through it. All clear. Vinny, all clear. Millie. Don't write all clear if it's not all clear. Decide not to write anything. Todo claro. Hey, we can't Latin now. Oh yeah, the papa. Even not joining from the start, I'm not lost. That's good. I'm not fully cleared. Oh, no problem. No problem. As we are moving on, and I'll post the file. Try to make it clear with you, okay? Now, Kojo, your hand is raised.
Say for those who are finding it difficult, can I use like only 2 minutes to explain to them?
Can you what?
Just 2 minutes to like give them the actual gist.
Okay. Give them the actual gist. Do I need to be scrolling? Or you can do it without scrolling?
They just have to listen.
Okay. So could you explain to them? 2 minutes. You have 2 minutes.
What you're trying to say here is just what you're trying to say here is just a rate of reaction. A rate of reaction, we are just saying something basic is that you see that amounts are products are formed or reactants are absorbed. And in this situation, always reactants will be absorbed and products will be formed. And now we come up with the formula saying that an element E, but this element we are considering its concentration, therefore we put it in square bracket divided by what? dt. Dt is like the time. That's why you get a definition as the rate of reaction is the amount of products formed per unit time. So literally the formula is talking about how the definition is the amount of products formed per unit time, the amount of reactants absorbed per unit time. Now, when they give you a chemical equation like what you are seeing on the board, 2N2O5 gives us 4NO2 plus O2. Now, when they tell you to express the rate of reaction for each element and product, it's simple. And when it's a natural or normal formula, you just write the formula in your head and just take, R, we said R is equal to this, that. But remember, we said what? The reactants are absorbed. If reactants are absorbed, then it means that their concentration are reducing. If you are absorbing something, it means their concentration is reducing. And if you are forming something is produced, it means the concentration will definitely increase. So we now term as R is equal to the differential of what? We write it N2O5 divided by dt. But no, it is having a more ratio or a coefficient of 2. Therefore, we divide it by 1/2. By a negative number because what? It is being absorbed. Now with the product, we multiply by a positive number because it is being formed. So with that one, we can say if maybe the product is CO2, we can say R is equal to D square bracket CO2 square bracket close divided by D over T. This is how it is. If you are having what coefficients that are not 1, we need to have a coefficient of 1 to satisfy our stoichiometrical values. If you are having coefficients that are not 1, you multiply by the inverse of it. Just say if you are having half, you multiply by 2. If you are having 2, you multiply by half. Like the inverse of it, reciprocating method. That is all.
Thank you. Inverse of it, reciprocating method. Now, if the coefficient is in any form, just find the reciprocating method. Simple. Now, reciprocating method. Now, what you say, and one. I feel real work. The same equations that I just did express the rate of reaction for each reactant and product. For each reaction, state which substance increase and which decrease in concentration. So N2O5 decrease in concentration, and NO2 and oxygen decrease in concentration. For reaction B, A and B decrease in concentration, and C, increase in concentration. For reaction C, nitrogen and hydrogen decrease in concentration, while NH3 increase in concentration. Question 3. For reaction A, verify that the rate of all reactants and products are equal in magnitude when properly scaled. So you would write the equation in their rate, then you equate all of them. Okay, they equate all of them. Then he said, for reaction B, if the rate A is this, calculate the rate of B, rate of C. Oh, good. So I told you that you can equate rate, right? So take this one, equate to this guy, and put this rate there. So when you put this rate there, then you look at the mole ratio. I'm doing that calculation. I've not solved calculation with you, so I'm doing the solution for only this one. So he said the rate of reaction B. So let me pick it up like this and write it this way. So rate of reaction B. So I think the B will be equal to the A, because I told you that you can equate any two of the rates. What I say. So my equity. Me equity rate, you know, I'm going to look at my reaction for reaction B. So let me go to reaction B. You see reaction B, the ratio, the stoichiometric coefficients are not something so straightforward or unitary. So for B, it is, let me look at it well. 3A plus half B. Okay. So A is 3. So I need half of that. And half B. So I need 2 of that. So 2 multiply this guy. And half multiply this guy. Don't get lost. Don't get lost. That is why you need to come to class all the time early. About the chemistry at this time, I'm not joking. The person who chemistry at least majority of it to make you keep guys exceptional. Now, after you have this, is it 1/3? Let's check it well. For reaction B, A is 3 and B is half. A is 3 and B is half. So 1/3. And B is half, so 2. So we are right. Now, after we are done, let us put in our value for A that he said. That is the rate of A. On no question, or the mind, or no my rate of A, no the pure one. Or say a negative 6, 0.06. Let me clear the negative there and write 0.06. Do you know why he brought the negative? To show that the A was consumed, okay? But you know, B was also consumed, so negative and negative goes off, okay? So I pick up this side, I fix it. So 0.06 for the A. But as Kai says 0.3 multiplying. The B, the meaning, and then I make sure. Into now, my main simple algebraic expression. I'll pick up the B alone with the equal to sign. I'll let it stand alone. Then I equate it to equal to. Someone should solve 1/3 of 0.06. What did it become? 0.02. Hey, 0.02, is that so?
Yes.
Yeah.
Yes.
When you are done, you can see that there is 2 in front here. You have not worked it out. Yeah, algebraic expression. Now you're divided by 2. You are dividing all the side by 2. So I finished expressing this one. I want to divide by 2. So I have to divide by 2. You divide by 2 for fair. That's how to do it. Okay. All the calculations are not difficult. They are very easy. 0.02 divided by 2. That gives us 0.01 as the final answer. And it is true. Let me write it. 0.01. It's true. When A is 0.06, then B is 0.01. Do you know why? Go and check the equation. When A is 0.06, see, 3 times 0.06, then B is 0.01. Because this one is halved. This one is times 3 of it, and this one is half of it, half of whatever value that we are having for A. But because of the stoichiometric ratio scaling, it gets us to that point. Think through it well. So A is 0.06. We fix that. We multiply by 1/3 of it because A was 3, so we want 1 pair. So we simplified that, and then the dB we multiply by 2. So we divide the 2, and we can get our final answer. So let me write it: mole per decimeter cube. I'm coming. Mole per decimeter cube per second. Oh, that's the unit for rate. What I say? Mole per decimeter cube per second, and that should be the final work. Okay, let me pick this mole and put it here too. The explanation, know how to explain. I told you is because we scale them, and we can relate all of them to the same ratio. Okay, 1, 1, 1, 1, 1, and so we can now compare. Now another question. That this one it contains solving. Like I solved one for you, so you should be fine with this one. I need someone to read this for me. Benita doesn't join class again. What's wrong with Benita? I need to find out. Hilda Bassi, you've joined class ever since I started. Read. Hilda Bassi, read.
Okay, sure.
Hilda Bassi, were you the one that won the Guinness record of cooking jollof? Are you the one?
Say no, it's me, Helen.
So Helen is joining with Hilda's this one. But why is your name Hilda?
It's my mom's name.
Oh, okay.
It's my mom's name.
Oh, I understand. So your mommy won the Guinness Book of Record. All right, let's continue.
Okay. Question 1.
Ellen, wait. So when we finish class, Ellen, please, you're going to give us some of the jollof. Thank you. So continue, start.
Okay. Question 1. Consider the reaction 3A plus half B into 2C. If the rate of disappearance of B is 1.5 times 10 exponent minus 3 mole per dm cube per second, determine A, the rate of disappearance of A, B, the rate of formation of C. Solution.
Thank you so much, Ellen. So what happens is that they're giving us a chemical equation. I think we've seen this equation before. We found it out. So let's just write all the rate of disappearance of A. Okay, we can write how it disappears, and we can write how the B disappears. B also disappears. Let me write the two negative there. So we show that it disappears. You get it? So when we are done, now we write the appearance of C. Rate of product is C. So now rate of disappearance of A. So he said we should calculate it. Disappearance of A. But he has given us the rate of disappearance of B. As you know, we can relate everybody. So we relate A to B. Okay. Then I fix the rate of B there. Because he gave me the rate of B in the question. So I have to go and fix it. Fair. So I fix it. Fair. You see, A and B actually have the same negative. They are all consumed. So 2 times the rate of B, I put the B there, is equal to 1/3 of the rate of A. So me solving 0.03 for this side. Then this one still exists. Okay. So I want 1/3 to go off. So I multiply through by 3 algebra. So I get 0.09. That's the rate of A. Okay. That's the same as, let me clean it and write the rate of A. Let me clean it and write the A over dt. I can write d over dt there. You get it? But I just write R of A. It means the rate of A. Then you get your final answer to be 9.0 times 10 to the power negative 2 mole per decimeter cube. So when you are giving calculative questions, just equate. Put in your rate they gave you and simplify. Just equate. Put in your rate that was given and just simplify. Let's do another example. The formation of C. So now that we have B, we equate that to C. Okay. And we put in that of B, and then that of C is half. So you know the C. Why did I do the C minus? No, it's showing minus shouldn't be here. Okay. So we multiply 0.03 by 2. We get 0.06. So rate of appearance of C 6.0 times 10 power negative 2 mole per decimal cube. I didn't add negative because it's appearing. And so you see the dB is actually negative. But in relation, I don't want to show it up. And I don't want to use the negative in my calculation. That is why I re-echoed 100 times telling you that the negative is only to show that it is consumed. I have to not use in my calculation. I don't need negative answers. I just don't want to use that in my calculation. Just focus on your work and do it. Forget about the negatives. Why? It's only to show us that it is consumed. Thank you. Now, you see the work. Come on. Let's send the file. You don't expect me that 2 hours. I'll do everything with you. Huh? Into me send the file now. No, I can't share. Many more years, I'm going to 2 sites. So, share. And then recorded sections. Not yet. If you don't go to classes, you have the greatest advantage. Listen to it over and over again. Okay. Assignments. But assignment is do the note on this file and send it to me by Saturday. Next week, Saturday. Before I have a class next week, Saturday, send it to me. I'll vet it. And then I'll look at it and see whether that's a concise and perfect note you have done there. Your note to say the okochra obiade there. Why your note no come obiate will note na say into as you wom come. Okay. So this work too is there. Let me put this one up. Another solved example. Oh. What was there, cry? I think -3 or so. 4 times 10 is a power -3. Yes. So the same work. If the rate of disappearance of hydrogen is this, determine the rate of formation of this. So write all the reactants and then the product. Then we equate of hydrogen and ammonia. Ignore the negatives. Why? Men find negative in your calculations. Why? Me part or why? Negative nature and say it is consumed. Keke. Yeah, find your calculations. What? Yo, me das. So you simplify and you get your work. It's scalar down quite here. Let me see. Hey. So Kayla has missed this class. Okay. So let's go on. So you get it. If you don't get it, forget about it. Maybe I'm doing it there. Once a machine and a match there, you know. Machine and match the war better rate. Mature in terms of the stoichiometric ratios, the war better on the war be OBBR. And mature the war, see your mouth dig it, and I see your mouth in terms rate for backward. What back ube equity. Now they are shame. Now our final answer. What have I done this whole time? I've taught you how to show stoichiometric rate, definition for rate, how to actually know the negative sign, importance of it, which one increase, which one decrease. I've taught you rate, and I've taught you how to equate them, how to write the rates, equate them, and then if you are given a value for one rate, how to put it in and then simplify your work. Now, finally, factors that affect rate of reaction. Now let's go. Factors that affect rate of reaction. Yes, I'll address the site. You know, I said I've opened for accelerated course 1. You don't need to sign in. You guys caused a lot of problems and headache. I was wasting my whole time on the site last time, so I couldn't teach much last back. Though it was 1 month, I did my best. I did calculus. I did. But because I was always running to the site to get people's names that I had to do videos, files, all the focus was now coding things on the site. So I've just opened it for everyone. Why? Just enroll and just go and click start learning. Period. Just these 2 instructions. If you have problems, then I won't resolve it for you because I don't want to waste time only on that part. So please just go to accelerated, click mastermindscholars.org. Go to accelerated course 1. Click start learning. That's all. Locate accelerated course 1. Then click start learning. Then click anything you want to search for. They are not uploaded until I'm done teaching you here. Then I'll put it there. Then you over the next day or the next time you check it and learn well. That's all. Now you guys, let's go. Factors that affect rate of reaction. I need someone to read it for me. I need someone to read it for me. You guys hurry up and let's close. The time is fast spent. Letitia.
Factors that affect the rate of reaction. Number one, temperature, concentration or pressure, catalyst, surface area or particle size or physical state, medium.
Thank you. Claudia.
The factors that affect the rate of reaction: temperature, concentration of pressure, catalyst, surface area, particle size, or physical state, and then medium.
Okay, good. So guys, this is the last part. I want you to get some of being or side way wrong. Who chile much will be a chile and say, oh, yeah, killer explanation way. Will be who's oh, yeah, killer or what you say. Into explanation where there's so show behind as a show fingertips. You have to, should be on your fingertips. You need to get solid understanding. It should come from your understanding, not necessarily memorizing. Understand it. Factors that affect rate of reaction. You are going to use collision theory to do the explanation. When I'm done, they will go off. Okay, the last part there. Yeah, I'm going to share notes. Maybe I many time at Chilemu, but mastermind students, they SLBO. Into me, yeah, me do last part. We are not going shame, but on Tiasia, you can relate. You can tell me. I'll check it out for you. That's all. What you say. Now, let's start with collision theory. Before you can understand, what's the name, we can understand how these factors really affect what's the name. Me say, before we can understand it, I want it on one page. You pay the words here. Good. Before we can understand, you see everything that is bolding. Them are bolding in Ninyina who explain here, you can't miss those ones. All the things that are bolding are the ones that you want me to explain, you can't miss until you're careful. We need collision theory to explain the factors that affect rate of chemical reaction. So collision theory. For a chemical reaction to occur, reacting molecules must collide with one another. Mastermind student, collide with one another. For a rate to occur, for a chemical reaction to occur, reacting molecules must collide with one another. It is so what you say. So reacting molecules must collide with one another. Not all collisions result in a reaction. Only certain collisions are successful. Not all collisions result in a reaction. Only certain collisions are successful. All of you guys are grown. Let me give you this scenario so that we can easily get it well. Spare me using this example, but it doesn't mean anything. It just means that I want you to get some concept. Now, if I want to have a kind of connection with, I'm a male, so if I want to find a connection with a female, the guys, if you want to find a connection with a female, you know what you do. You first go to have an acquaintance with the person. You talk to the person. Oh, what is your name? Where do you come from? How are you? Where do you go to school? You see that thing? It's called, you are having an acquaintance with the person. Before a reaction can occur, before you guys can have a kind of relation between the two of you, there should be a collision. There should be a reaction. There should be a conversation. There should be a spark. There should be a start up. In chemical reaction, we say there should be a collision to occur. The same even applies in human interaction. Am I right? Yes. But you know, boys, it is not all the reactions that you go. Sometimes they'll bounce you. I'm checking it. Steps. You get it. But not all the collisions, all the reactions, and all the conversations that they will accept to. They'll bounce you. Yeah. Oh, shit, Charlie. Pressure off. So you get it. Not all collision results in a reaction. Only certain collisions are successful. So only the ones that you speak well. What can say, Charlie? What present? Come on. What trend is where a brella boy. You actually show yourself well. You see, you aligned yourself well, and that's one day. Only few one of them would accept it. So you get it. Only few of the collisions that occur will actually result in a successful collision. That's collision theory I'm teaching you here. It's called acquaintance theory. Like you meet the person, you talk to the person. Not all the things that you say, or not all people that you say the same things to will actually result in effective friendship. Now, what are the effective ones? The effective ones are the ones that you spoke well. You show yourself very well. So effective collisions are those collisions that lead to chemical reactions. The one that you spoke that led to a reaction or led to a relationship between you and the person. Only a small fractions of all collisions are effective. Every day, only small fractions. If you like, go outside and talk to 10 people and see whether you can make all of them have a good reaction towards you. Share. I just say be a Prince Charming. You get it? So only a small fractions, okay? And even those fractions, they should have certain orientation. It should be head-on. Head-on means that the colliding molecules should face each other. When we are punching, in punching me, that is called head-on. Head-on collision. I was watching a video on somewhere, and then the two goats. One goat hits the other goat. And I continue to know share back on himself. Ish, I don't know why. That is head-on collision. That is head-on collision. I thought you said you are not hearing whatever. I know, right? I know, right? Gideon, you say you don't hear anything. Oh, I'll answer it. Loretta, I'll bounce you. Gideon, I will not come. You guys are happy. Oh, it's better now. It respond well. Says started to solve. Okay, that's good. So you guys get it. So first of all, you have to have an acquaintance. That's first of all. There should be a collision. Secondly, make sure that the collision is effective. Not all of them will be effective, of course. They should be head-on so that it will be effective. Like the goat way of fighting, it should be head-on. The molecule should be head-on. To overcome the energy barrier, there is something that last thing. Then we'll finish. Last thing. Whenever they have that head-on collision, it should produce some kind of energy, some kind of attraction. It should overgo the activation energy. Activation energy is like the girl's barrier that they have created for themselves. So when you talk to the person and breaks that barrier, then the person has said, "Oh, I also like you as a friend. We want to talk. Take my number. Call me anytime." You get it? Why am I using this as an example? It doesn't mean there's nothing bad. Okay, let us just have this kind of human interaction, using this human interaction to understand collision theory. It doesn't mean anything bad. So to overcome the energy barrier, that is the activation energy. Only the most energetic molecules can participate in a reaction. So then when they hit head on like that, the energy becomes higher accumulation of energy, and then they'll be able to overcome a barrier called activation energy. Activation energy is the minimum amount of energy that colliding molecules must reach so that they can create a reaction. Activation energy is the minimum amount of energy that colliding molecules must have, the kind of energy they must reach, so that they can now start forming what? Product. Oh, class has been interesting. You guys get it? So collision theory. Number one, they must collide. Number two, not all collisions are effective. The effective ones should be head-on. The effective ones should be head-on. And then the energy barrier. The energy barrier, the colliding molecules that have good energy after the collision are the ones that can cause chemical reaction. That's all. Now, with that idea, now let's think through something here. Surface area. How does surface area affect? After the factors, I'm done. Okay, there you go. The last part, I'll go through it some other time. If I get some small time, I can go through it. If now surface area, I need a male to read this. I need a male to read it. Gideon Hammond, read. Gideon Hammond, read.
Surface area. If one of the reactants is solid, increasing its surface area, for example, by crushing it into smaller pieces or grinding it into powder, exposes more particles to the other reactant. This makes more particles available for collision, increasing the number of collisions per second and consequently the number of effective collisions. As a result, the rate of reaction increases.
Thank you. Guys, I need you to look at something here. increasing the surface area. Let me bolding it. Number one, what does it do? It exposes more particles to the other reactants. It exposes them. I need OC. It exposes them. It makes more particles available for collision, increasing the number of collisions per second. Hey, what have I done? Increasing the number of collisions per second. And then what? Increasing the number of effective collision. The ones that are bolding, if you don't write it, beans. Why is explain crank? Why? The one that are bolding, if you don't bring it, when you're talking about surface area, forget the what wrong. Papa. The one that are bolding, explaining surface area, that's one fan bar. Forget the what wrong. And papa. If one of the reactants is a solid, when you are creating a chemical reaction and one of the reactants is a solid, make sure that you increase the surface area. How do you increase the surface of a solid? Crash it, so that the particles will not be available for collision. Now they are to assume that burn a reaction in the naphthalene a blue, auto blue na in the granular one. And now this change that burn a na I blue kama uniform and sand wait me at arena sheet. Crash it, put it into a bottle, soak it first before you pour it into the water. You made the reaction faster. You crashed it. You made the collisions of the particles, more particles available for collision to make it very easier for the rate to occur, for the reaction to occur. So if one of the reactants is a solid, increase the surface area by doing what? By crashing it into smaller pieces or grinding it into powder. This will expose the particle to other reactants. And it will make more particles to be available for collision. Therefore, when there are more particles are available for collision, there will be more increasing number of collision per second. And then you find out that the number of effective collision will also increase. And then the result is that the rate of reaction increase. So number one, crash it to increase surface area. Number two, if you crash it, the particles now become available for collision. Number three, when they are available for collision, it will increase the number of collisions. When the number of collisions increase, the number of effective collision will also increase. And then finally, the rate will become very fast. Remember, if there are 10,000 collisions, only about 50 will be effective. Do you get it? I'm just exaggerating so that you can see why not all collisions result in effective. You get it? In that regard. So take note of that. Who can explain surface area for me? I'll scroll down. Then you tell me in your own words. I want you to explain it like you understand in your own self what you are saying. Now you catalyst. Yes, one extreme. How does surface area, increasing surface area, affect rate of a chemical reaction? Habiba Mohammed. Habiba Mohammed, you can talk.
Okay, so increasing the surface area of a substance will decrease the rate of reaction. So, for example, if you want to dissolve salt in water, let's take this example of our local salt, Adantini, and the hydrated one, UC, in different containers with water. The hydrated salt will dissolve faster than the local salt because the surface area of the hydrated salt is smaller than that of the local salt.
Okay, you missed just one thing, the last statement, because the surface area of the Adantini is small. Surface area is small rather. Once at the end say a ball, surface area is small, but a powder surface area is large. Surface area means that it can cover a lot of area. Say a ball or the two tables, so I cover small parts, but say a granulated or powdered, or the two tables, so I be taking up a lot of space. What I say in that regard. So no one should miss surface area in terms of when it's a ball or granular, it is small surface area, but when it's powdered, it has large surface area. Could you answer?
Okay, so we are talking about rate of reaction. Right? So let's think in a sense that products and reactants are formed. Now let's relate this to diffusion in osmosis. The larger the surface area, the larger the rate of diffusion. This one too, the larger the surface area, the larger the rate of reaction, such that if I'm having a cube of sugar and I'm having powdered sugar. If I pour if I pour the powdered sugar into the Milo and I stir, because it's already powdered, it will start dissolving fast. But with the block one, it covers a small area. After a bare powder, as will cover large area before it will dissolve, before the rate of the reaction will occur, making its rate lower than that of the one which covers a large area.
Thank you. Now, I want you guys to explain it in terms of chemistry. Habiba Mohammed, I recognize your explanation. Perfect explanation there. I love that. Kojo, perfect explanation there. I love that. Now, I want you guys to know how to explain in terms of chemistry. When you are asked this question, explain how increasing surface area increases the rate of reaction. Use kinetic theory to do the explanation. Use kinetic theory to do the explanation. Talk like this. If surface area is increased, rate of reaction increase, and this is because when we increase surface area, for example, by crushing the solid into pieces or granulated or into powder, it exposes the particle to the other reactant. This makes the particles available for collision, and this increases the number of collisions, and as the number of collisions increase, the number of effective collision also increases, and finally the rate of chemical reaction increases. You see, I have to even add the last part. The number of collisions per second increases. Consequently, the number of effective collision increase, making most of the particles have energy that is greater than the activation energy, and hence the rate of chemical reaction increases. Making most of the particles attain energy equal to or greater than, am I doing the right thing? Greater than the activation energy, comma, full stop. As a result, what I say, sentence when I'm the back count is saying, what I say, making most of the particles attain energy equal or greater than the activation energy. As a result, the rate of reaction increases. Explain in terms of chemistry. 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 Kojo.
Okay. So now our goal here is to form a chemical reaction, right? And for a chemical reaction to form, then reacting molecules must collide with each other. So when the surface area is increased, the rate of reaction is increased because substances are introduced into other they are introduced to the other reactants, which gives a room for collision between the reacting molecules and the other reactants. As a result of this, most particles or molecules obtain the activation energy, which is the minimum amount of energy a colliding body must reach to produce a product. and as a result, this confirms the fact that larger surface areas produces results of larger rates of reactions.
Thank you. Thank you, my boss. Thank you, my boss. All of you should explain it in terms of chemistry whenever you are asked, okay? Then you supplement it with the explanation. When you're explaining to people, you supplement with the explanation with the granular salt and all that, you supplement it with that. But when you're explaining, use collision theory. That's why I explained collision theory before we started. Now, finally, catalyst. Hey, one will be in Saudi, your friend say, that thing, oh, potassium nitrate. I've forgotten the name. It's yes, kanwu or something like that. It would make sure that the beans being fast. It's called a catalyst. It's a positive catalyst actually. Potassium nitrite. It's potassium something. So effect of a catalyst on a rate of reaction. A catalyst is a substance that increases the rate of chemical reaction without being chemically changed or used up. It will not be used up. That is why when people eat beans with that thing in there, they really run. The reason is it is not used up, and that thing too is a chemical substance. So it affects these digestive processes in the human digestive system. Cause people to have stomach discomfort because it's not used up. So it will continue to be reacting in your stomach. Mo blare off. And I'm more blue with also. Now I'm beans, not to say more yen nema. Let's laugh some more now. Hey, go before more blue. So if you find out that the catalyst it will not be chemically used up. Okay, let's continue. So look what here. It works by providing you see guys, I don't mean pair off. Oh child in Asia is all being on our child in Asia. It works by why catalyzed? Unanalyzed. Add to dictionary. The any catalyst that you add to a chemical reaction, it actually creates an alternative pathway. That alternative pathway has a lower activation energy. So let me tell you something. If colliding molecules need 200 joules so that the product will be formed, when CANWO comes, it won't need 200 joules again. Colliding molecules will now need 10 joules. Can you imagine 10? Yes, to form the product. That is why you don't need to be in terms of it takes 1 hour. CANWO need 20 minutes. And the reason is because it works by providing alternative pathway. It lowers the activation energy. It lowers the energy that you need to form product. So that is what catalyst. So when I ask you, when you see anyone asking you what is the effect of catalyst, the thing that should be in your head is alternative pathway. Alternative pathway. Hey, all of you type alternative pathway. Type it creates an alternative pathway with lower activation energy. Type it for me. It creates an alternative pathway with lower activation energy. Type it. It creates an alternative pathway with lower energy. It creates an alternative pathway with lower energy. Clinton Rex has done it. Mikhail has done it. Loretta has done it. Alex, Gideon, Buahima Mili, Awin Pati Pius, Bess Makedulina, Sophia, Melissa, Millicent, Diane, Samantha, Prince, Kojo, Yvonne, Priscilla Amagala, Claudia, Hilda Bass, Ellen, Vinny, Augustine, Jeffrey. Good. Never forget this sentence. Never forget this sentence. Anytime I tell you to type something in the chat, it means that you need to keep it for life. You need it. Never forget this sentence or phrase. Last person, another 2 people have added. John. Yes. Never forget it. Never forget it. So keep it. Okay. So because the activation energy is reduced, now you guys, when you're explaining in terms of chemistry, you say that how do catalysts affect the rate of chemical reaction? Then you say that when a positive catalyst, you see, a positive catalyst will make it fast, okay? And a positive. Catalyst can be negative. Ebia all no beans. Now the enchine akogum. Enchine a negative catalyst. Emanem be in term that. We ask the girls. Boys, you there, you don't know, you've never cooked beans. Ask the girls. Hey, ask some girls. Ask some. And then ask some girls. Oh my goodness. I say I cook shit. And then Papa Bena could over to me. Hey. All right, so let's finish. So you find out. You say that you say that if positive catalyst is now added to a chemical reaction, it provides an alternative reacting pathway that has a lower activation energy than the uncatalyzed reaction. Because the activation energy is reduced, a greater proportion of the reacting molecule now have energy to collide effectively and form products. This increases the number of effective collision per second and thereby increasing the rate of reaction. In that regard, omu here 1,000 joules, say omu here 100 joules. Collision kit will be na for me effective. Collision kit will be na for me effective because catalyst no I reduce it standard no. But I think it will be a pass exam no, to decompose hydrogen peroxide into water and oxygen gas. I'm showing some few catalysts. Okay, catalysts now I've explained simply. Catalysts provide an alternative pathway with a lower activation energy. Because of this, a greater proportion of the reacting molecule now have energy to overcome the activation barrier during collisions. They have energy to overcome the colliding barrier, overcome the activation barrier during collision. They result in more effective collisions per second, thereby increasing the rate of reaction without the catalyst being consumed. So these are some few stuff on the catalyst that I wanted you to see. Now look at some few reactions that I researched. Considering your standard new curriculum and all that. The composition of hydrogen peroxide, manganese is the guy that will do the work. The composition of potassium chlorate, manganese iron oxide. So manganese iron oxide or a catalyst raw off. A catalyst. It reduces the activation energy, allowing oxygen to be released faster on gentle heating. Organic reactions. Hydrogenation of ethene is called addition reaction of ethene. Nickel or platinum will do a faster help hydrogen and ethene molecules to react faster. Esterification. You guys, you don't know that esterification is important. Sulfuric acid, concentrated sulfuric acid, is a catalyst to esterification. Esterification is when an alcohol and alkanoic oxide or something form ethyl and what form ester and water. Alcohol and alkanoic acid combine to form ester and then water. And this is an ester, the one I've highlighted. Okay. And then you have industrial process, Haber cycle, Haber cycle, ammonia production. This ammonia production saved the world one time and also caused a lot of destruction. I'll explain to you later on when I'm explaining how Haber now created the ammonia decomposition process. Ion does it so well. Contact process, sulfuric acid production. Vanadium is also a catalyst. I'll send you. Oswald process. All this one they've asked in WASI before. If not it, I wouldn't have shown it. Platinum and rhodium gauze actually does the catalyst very well when it comes to Oswald's process of nitric acid production. All right. Now we are done. Okay. You can go and relax. Then we can take this again from another time. Go and learn how what's the name? Temperature. Hey, man, I thought I had done it. Oh, then I didn't add temperature and this one. Temperature and all the explanations. When you increase temperature, it increases the kinetic energy. So they hit faster. That's all. When they hit faster, collisions are more, effective collisions are more, then the products are more. You get it? When you increase temperature, it just increases kinetic energy. When you increase concentration, it just increases the number of molecules. Concentration, the number of molecular particles not also. Into normal produce more collisions, more effective collisions, then more faster rate of reaction. Today I've done rate, I've tried. I've done almost half of it. The last thing is showing you these calculations, the energy profile. This is the activation complex. It's the point of then the activation energy, the reactants, then the products are formed. This is for endothermic. Heat is maintained inside. I will explain later on. Heat is maintained outside. I'll explain later on. Then we come to the rate law. Then we are done. I'll show you some calculations on rate law, give you some few assignment for you to do. But I'll send a file. Start working on it first. Start working on it and check all. My file, when you read through, you can be fine, okay? But I didn't know I didn't add the temperature and the concentration. I'll add those ones. Now, my senior mom, Namushia. Why? All right. Thank you very much for joining in. Monday, I have a powerful motivational class for you. And next week, I am doing perimeter, area, volume. I've called it mensuration 1 and 2. I'm doing all of it. Cones, cuboid, cubes. I'm doing area of a sector, those sector segment. I'm breaking it into 2. Then from Monday, I'm doing that. Then during that same week, that Friday, I'll do physics, 1 topic in physics. I'm thinking of atomic, but let me see. One that would really impact you. Then I'll do something else. I was thinking of doing another elective maths topic. So thank you very much for joining in class. You've done well. I've recognized all of you. Abigail Hagan, Millie is here. Abigail Hagan, I think it's Michael Hagan. Alex, Elom Elliott. All my bosses are here. Jeffrey, Fafali, Habiba Muhammad, John. John, next time use your full name. Lena Graft. Letitia is here. Loretta. Madia is quiet but always in class. I like that. Sheila, I don't know you. Sheila, who is Sheila? Sheila, how are you? Sheila, how are you? You save your name with Sheila. Okay. You don't respond, that's fine. You just risk not joining class again. If you want to find out your Zoom is not working, me and I'm here. Why? Sophia Ijapoma, Veronica Amwa, that's good. Vinny and Winifred Amezo, that's good. A Suman, Princess, okay. So I think that is it. Thank you for joining on in class. Letitia, pray, let's go. Pray. I'll send a file to you. You guys should do it for me. So now I can give you guys assignment. What I say? See, make my mama assignment. What I say? My mama assignment, and so I'll give you assignments for you to do. Let me see if I can give you assignments now. So you screenshot, then you do it and send it to me. I'm coming with. Oh no, this assignment. No, it's rates law assignment. Okay. Do this assignment for me. Let me go back. You remember that assignment? Do this as assignment for me. This one. Example, once when we went down, there was a solution question there. Yes, this one. Consider try work. Do this try work for me and submit to me. The hint is there. Hint every day, everything is there. So let me Control N, Control V. Good. You can take screenshot. When I finish, I'll send it to you too, so there's no cause for alarm. So try work 1. It's your assignment. Submit it before Monday. You have Sunday evening, Sunday dawn. Before Monday, just submit it before Monday. You have tonight to do it. Let me add one last question to it. So A, B, C, D.
We can't see.
Okay. Oh, I didn't share that screen. This assignment. Consider the reactions A, B, C. I express the rate of each reactant and product. For each reaction, state which substance increase and which decrease in concentration. For reaction A, verify that the rate of all reactants and products are equal in magnitude when properly scaled. So properly scale them and equate them for me. If you properly scale them and equate them for me, it means that you are correct. You don't need to do any further explanation. For a reaction, this A is this, calculate. I've done hints for you. I've solved the B for you, so solve the C, okay? Then 5. for reaction C, if the rate of formation of the, so solve that one too. Explain why all the rate of change. Then question two. State 5 factors that affect the rate of a chemical reaction. So reaction. Don't go, wait, small. I'm giving assignment so that you do for me. I'll check it. I'll check everyone's work. This assignment is essential for me. I'll come back on rate to do the last part of rate. Today, I've divided rate into 2. I've done the best rate class that can ever happen anywhere. So I've done the best rate class. I've taken my time to explain everything detailedly. Everything I've told you is true and it's correct and it's right. Learn more on it to get better understanding. So question 2A. State 5 factors. 2A. State 5 factors that affect the rate of a chemical reaction. Explain B. List. Explain the collision theory as associated with rate of chemical reaction, or as associated with chemical reactions. Explain. Melissa, explain the collision theory as associated with chemical reactions. C. Briefly explain how the rate of a chemical reaction is affected by the following A or I, temperature, and then I, what did I say again? Surface area, and then I, surface area, concentration. Me person mo ye we mama na mo send mama. Obi obeye bia me wo ye me work me bomb pa ese Yakopon bo akra na wo umbin wanye work no kana wo ye mehi na wo ye mehi wo ye so no wan basa so wo ye mehi. So there's the work. So I'll post it on the platform so that everybody will have it. Assignment. Your deadline is before Monday. Me person Monday, but now be sending me a file. Now catch say I'm sorry. Then the amachinya jinasuna ye work no. Which me jinasuna ye work na san wada. Gisua de yi. Nti hwe file no nesua ye work no mame. Na send before Monday. So this is the work. So let me write deadline. So let me write assignment, chemistry assignment. You can go, we are done. If you have something to do, you can go. If you want to relax, you can go, but I'm just writing the assignment for you. Chemistry assignment. Today is 27 to 8 8 November. All right. So clearly answer all the questions and scan your answer into a PDF and submit before Monday. What's Monday's date? Today is 8th, 9th, 10th, right? 10th November. Thank you. So I think this is fine. So all clear. Let me now make sure that this part, I make it into small parts so that everybody can see things well. Assignment. Don't play with my assignment. Don't play with my assignment. One of my assignment, I mean, who cry? Oh, say, mommy. like, I just say, what should that? I before any assignment. I before. I before any assignment. Let me add and remove so that we can everything can be fine. Yes. Just what I know before now person tete my bra bo mama. One person be you mo ekran mo hu se usua de. Nti what I know before now person me real ho, person me real ho. If you omo no mo nya assignment. What I know before person tete me. All right, question 2. State 5 factors that affect the rate of chemical reaction. Explain the collision theory as associated with chemical reactions briefly. Yes, let me reframe these things very well. So do that for me. Does any of you have contributions? Then we go. Or say, hey, say, I'm power. Before any homework. That's how person nipa na real. Person ni beji. Person ni beji. On the scale of 1 to 100, how did you understand the class today? On a scale to 1 to 100, on a scale of 100, Clinton, perfect. Claudia, 100, 85, 95. I like your percentages. I love your percentages. Charlie, hey. Mankasana, hey. Mankasa, me a guy. But you guys make me happy. Make me happy. You are learning. Explain why not all. Aha. Using collision to explain. Okay, draw and profile showing the effect of catalyst of following describe the chemical reaction. Study them. Suggest one reason the difference in the chemicals. Explain. Okay. So I think we are good to go. Let me add one last question. I took up. So last question. A student writes the rate of disappearance of a reaction without dividing by its stoichiometric coefficient. Explain why this could lead to confusion when comparing rate of different substances in the same reaction. Or one divided when divided, or so higher drink into when divided. Or so hard. Yes. State the collision theory. Let me make it state the collision theory of chemical reactions. State the collision theory of chemical reactions. So that becomes standard question of chemical. Briefly explain how rate. They briefly explain why not all collisions of a particle end up in chemical reactions. Let me add it to C. Explain why not all collision between reacting particles lead to chemical reaction. Explain why. And D, briefly explain how rate of reaction is affected by the following. Briefly explain how rate of reaction is affected by the following. Menfa A and koyem bremi. Ti adenase. Makacho. Using the collision theory, explain how each of the following affects the rate of. Okay, I like this question framed like this. Surface area of solid reactants. Let me put the question like this. Using collision theory, explain. Okay, good. So we are good to go. So A, B, C, D, and then E. Oh, thank you, Jesus. You've helped us to go through this night well. We've utilized our time very well. We thank you for all that you've done. So you see, we have done a chemistry assignment, question 1. Let me write this as question 1. So question 1. Express reaction no, A, B, C. So I, V, and then V, and then VI. Okay, then question 2, A, B, C, D. Okay, let's make it I. No, it should be the same way. So, good. That's all. So, yes, thank you so much. This question 1 is just one question. Okay, so it's just one question. Question 1, A. This one, the part this one is alpha beta. I should make it alpha beta gamma so that that'll be easier. The question should have been nice. So I, all that, but it's okay. All right, thank you very much. Say please, I want to speak to you. Inshira, after class, I think it's late now, but you can text me on WhatsApp. I'll respond.
Okay, sir.
So text me on WhatsApp.
Thank you.
You are welcome. If you will call me and it doesn't matter, you can call me too. Okay, so bye. Thank you guys. Oh, yes. Please, Letitia, please kindly pray so that we go, okay?
Okay. Our most gracious and everlasting Father, we give you all the glory for a successful session once again. Father Lord, we thank you for your hand that has been upon us. We thank you for giving us the knowledge to be able to comprehend what we studied today. We are so grateful, Father. Father Lord, we pray that continue to give us understanding and wisdom when we study. Help us to be able to understand. Help us to be able to comprehend. Help us to be able to remember. Give us retentive memory to be able to remember everything that we learn. We pray that Lord continue to give us the grace and the strength to study. We pray that Lord take away every laziness, unmotivation, undetermination away from our lives and help us to be able to strive and study so hard to make our parents proud, to make Prof proud, to make you proud, to make everyone proud of us. In the name of Jesus. Father Lord, we pray that this weekend and in this week too, we pray that let no weapon fashioned against us prosper. And let every tongue that rises against us be condemned in Jesus.
All right, so we continue. Guys, these days I've been going through a lot of inconveniences, pal. I don't know why. Please, can you hear me wide and clear? Can you hear me well? Should I continue? Is my background noisy? I relocated, so check it out. Can you hear me well? Let me know in the chat so that I continue. Real. Okay, they can hear. All right. So the rate determining step is the slowest of reaction that takes place in more than one step and helps to find the order of a reaction. You guys, I taught you bonding, right? And I told you that when you have a reaction like sodium solid, I'm using this as a hypothetical explanation, please. It doesn't mean exactly perfect this one like that. I want you to understand rate determining step. Say the other time, no, I'm using hypothetical understanding so that you can understand better. So you have Na solid and NaCl. When I taught you the series of reaction that goes on before NaCl is formed and the lattice energy that undergoes there. You remember when I taught you that? I said that when sodium is in solid like that, it has to be broken down and come to become gas. So sodium like this will come sodium gas. Turning sodium to sodium gas alone is going to give you enthalpy change, or we say energy of solid to gas sublimation. Okay, sublimation. Then when we change from sodium to give out one, that will be ionization before the final one. Then we come to chlorine. Chlorine is 2 molecules, so you have to tear it into 1 molecule before you can start sharing. So chlorine coming to chlorine 1 will just become enthalpy or energy change of dissociation, or atomization. You want to atomize. Then it comes down to now receive the one, okay, from sodium. That one's ionization energy. Fine. Okay, you guys understand. You see the series of changes that undergo sodium chloride before it can form NaCl. You see the series of chemical reactions. First chemical reaction, Na to Na gas, then Na gas to Na ionization energy, Na plus, then chlorine to chlorine itself as it become atomized, and then chlorine now taken into electron affinity. If you don't understand, don't worry. It means that you are at our back. Oh, yeah. Now you have, after you have that, you have to now add all those sum of reactions up to get the lattice energy for NaCl. Fine. Now these are series of steps that NaCl must undergo before it can be formed. These series of steps are series of reactions that goes on, and because of that, we need to find the slowest one and say this slowest one will help us to determine the rate of the overall reaction. So the slowest one is the best ideal one to help us to find the reaction itself. Why the slowest one? Of course, and biggest, largest one on the ABI checking in rate no slower, overall rate near slower. So the average, let's take the average. The average one, you are taking the smallest one so that we will be on the safest side, so that we will be able to use that one to determine the rate. We will not take the fastest, we will not take the intermediate, we are taking the slowest step. So rate determining step, or the one that we use to check rate all the time, is the one that actually the slowest step of a series of chemical reactions. Or rate determining step is the slowest of the reaction that takes place in more than one step and helps to find the order of the reaction. I don't like the way I've written it. Rate determining step is the slowest of step for a particular reaction which takes place in a series of reaction. What you say? You find a mama chemical equation. That chemical equation needs a series of steps to before it can form product. So those series of steps, I'm going to choose the slowest step. That slowest step is called rate determining step. Does it make sense? If it makes sense, talk to me in the chat. Does rate determining step make sense? Does it make sense? You know, come here. Okay, so just like maybe we are all running a race. We are all running a race. It's a relay race. The slowest guy, me, Kojo Asante, Elium, and maybe one of the Ella, we are running, and we are running together, and they are saying that our time that we reach the finish line, all of us reach the finish line, is the time that we actually finish the race. So how would they know our speed? They will take the slowest person's speed, and so that's the time you guys finished. You get the slowest person. That's the time you. Oh no, you not be the last. No, I don't know. In that regard. So the slowest step is actually the step that actually helps us to determine the rate of a reaction. I'll ask you a question about redetermining step, guys. I'll ask you a question. Now let's get to work. Let's get to work. Someone should read and let's answer this question fast. I need you to do that. Michael Abraham. Read. Michael Abraham. Nowadays, when I call you and you don't respond, you should come and give me a reason why. Because I don't understand why you should join class. I'll call you, you not respond. Winifred, read.
At a certain temperature, an alkyl bromide reacts with hydroxide ions in a one-step process as follows. Alkyl bromide plus hydroxide reacts to produce ROH plus bromine. I. Write down the rate equation for the reaction and give the units of the rate constant. II. What is the order of the reaction? III. What will happen to the rate of the reaction when the concentration of the hydroxide ion is tripled?
Okay. So this question is asking us. I don't know why this one is not making straight. It's not becoming straight. Okay, no problem. Okay, I'll fix it. So now write down the rate equation for the reaction. So rate equation becomes easy. R is equal to the rate constant K, and then we have the RBH RBR, and then the proportional this one. We are dealing with only reactants. I've not got to chemical equilibrium yet. Only reactant in T. Now so this is it. You get it. Respective powers. 1. So we don't need to write. You get it. So I've written it. What is the order of the reaction? Who can tell me the order of reaction and explain why? Tell me the detailed stuff. It doesn't mean you talk plain to, like, tell me the detailed stuff of the order of the reaction. Yes, Kojo?
The order of the reaction is given as 1 plus 1 is equal to 2. This is because order of the reaction is the sum of the concentration of the reactants. Yeah, because the order of a reaction is basically the sum of the concentration of their reactants. As in,
perfect.
The order of the reaction is the sum of the powers to which the concentration of reactants are raised to, like in a rich low chemical equation.
Perfect.
So you add the numbers of the concentration of the reactants to get your order of reaction.
Perfect, guy. Perfect. So now that is that. That's the order of reaction. Now the third one. What will happen to the rate of reaction when the concentration of hydroxide ion is tripled? Now watch here. This thing, my friend, bro. Oh, this one. write the equation and give it unit. You guys, you didn't let me write the unit. So the first one, write the rate equation for the reaction and give it unit. Give the unit of the rate constant. Whenever you're asked to give unit of the rate constant, you write the rate equation. There's a rate equation. Guys, watch it. There's a rate equation. The unit of R, PR, and OH. So R is mole per decimeter cube per second. It's rate. You guys know that the decimeter cube per second, time is up, down, dt, and then d of the concentration at the top. So mole per decimeter cube at the top, and time at the down. So mole per decimeter cube per second. And then the RBR is in concentration, so mole per decimeter cube, and the OH is in concentration, so mole per decimeter cube. Let's try that. Have you seen? Mole per decimeter cube per second, that's for the rate. RBR is mole per decimeter cube. OH is mole per decimeter cube, right? Now, let us represent them in the rate equation, and then let's simplify. So, midobia will be also rate in terms of unit, rate in terms of concentration, first one in the second one in the. Me pe K there no. Intimidate conform anyway, you never class here. Change of subject. Conform anyway, you don't be class here. Intimidate. Once you know class here, K number. More per decimeter cube per second is at the top, and then these guys are at the down. Indices, law of indices. I taught you indices well. More times more. Ebe more mienu. More times more. Ebe more mienu. Ebe more is a poor 2. I didn't even solve it here. Let me solve it. Let me add that step. So it's here. Oh. So down for the down here. More no be more per dm cube. Let me copy this and put it here. So then let me write more. So it become more per dm cube. But more becomes 2 because more one here becomes 2. Let me clean this one therefore. And then the dm per dm is minus 2. Take note. If I don't write the dash, I should be writing minus at the top. Like that. Okay. Mamini dash and I'm in minus no more. When you guys are use the minus. It's more better and faster and better. Amount to me on your man tempted. Anytime we study something here, you find out that you don't get the understanding. It means that you are really far behind. Inti. Ubekwa ko jiri wonu we shian temtem. Sana eno. The media don't understand no akakoda. Media don't understand no akakoda. Science student. Medical students went to write they say Legon, opeso call Legon call medicine. Ubekwa to exam ansana yafa umpo. So they went to write exam. My best mentee, the whole country, I can tell you that this guy is super smart. He's almost like a superhuman. Imagine 6 A's in the first one, 7 A's. On 35 over 70. And in his room, the people there were about 35. In his room, he topped. The second person I think got 34, 35. Over 70, not as a half. Not as a question, because this guy is super smart too. So imagine. You know, what person call medicine? Men for one and come medicine. For one sa, a year juma. So what am I doing now? Let me pick up the S well. I'm changing all my units well so that I become very cool. This question I'll give it to you in assignment. So I want to represent it well. So mole per decimeter cube per second, mole per decimeter cube again, and the down becomes more times more by mienu na matrono. And a minus 3 plus minus 3 by minus 6. It means a sum. Minus 6. So final answer. You see, the mole at the top will cancel the mole at the down. It become mole back pair of 4. The DM will cancel the DM. So the 3 at the top, it is like minus 3 minus 6, which you can minus 3 plus 6, which you mean minus 3 plus 6, right? Minus 3 plus 6, very simple. Minus 3 plus 6. It will give you 3, positive 3. Guys, am I right? Then the DM should not come down. Am I right? Is that clear? Are you guys here? So mole per decimeter cube. Then the mole cancel the mole. Then the DM. So the mole down here is correct. But the DM minus 3 all over minus 6. Okay? Minus 6. Into minus 3 minus 6 will become plus, right? Minus 3 minus 6 will become minus 3 plus 6, which become 3. 3. So the DM will go down, will go up, because minus 3. So when we even cancel out, we get 3, positive 3. So the DM comes up. Is that so? So when it cancels, it becomes DM raise the power 3. So let me write the DM raise the power 3 at the top. Jeff, I'm coming. So I have DM raise the power 3 at the top, S minus 1. Then mole cancelled mole, right? So mole will be power 2. So let me pick it up. So I think there's the final answer. Mole power 2. So DM raise the power 3 per second. Mole minus 1. K is equal to mole minus 2. Sorry. Mole minus 2. DM 3. Second. So that's it. Am I right? Is this correct? Let me check again. The mole become 2 down here. Cancel 1. So when it cancel 1, Rebecca back up. So more. So here to be more. Minus 1, right? So minus 1. Okay. So I think now there we are cool. We figured it out. Good. So that is it. Let's do. It looks a little bit crunchy. So let's continue. R is mole decimeter cube per second. RB is mole per decimeter cube, and OH is mole per decimeter cube. So I represent them the way they should be, and I write the K. So now this time I'm using the negative so that I can easily simplify. I start with the down. Mole times mole give me mole squared. So I do that. DM raise the power minus 3, and then DM raise the power minus 3. You can DM raise the power minus 6. 1 mole cancel 1 mole. It left it 1 mole down there. And minus 3 minus 6 become minus 3 plus 6. Then I get DM raise the power 3 at the top. S was untouched. That's raise the power minus 1 was untouched. Then I have DM raise the power 3 at the down. Right? Oh. DM number cancel or down. Masamba. See. So final answer become per mole DM cube S minus 1 in that regard. So now I think it's clear. Let me verify this. I don't know why this is. Okay, so we are right. You are right, Jeffrey. Okay, we are cool. So we are cool. It's correct. So take note of that. Okay, guys, take note of that. Write the unit. We are finding this is here, Jumano. Find this is here, Jumano. Now make kind of boy I said I'll analyze it with you. So more multiply itself by squared. DM cube needs to be minus 6. Mo no be cancel baako. Ebeka baako of form. DM cube no. -3 no so no. Ene -6 no be than +3. Into me the +3 na basro. X so your -1 untouched. When I finish, I wrote it nicely. Per mo DM cube per second. Young twaso. Another assignment. So this one is supposed to be assignment, but let's work it out. Look at the assignment I gave. What is exothermic reaction? What is endothermic reaction? Explain the effect of catalyst in a chemical equation. Illustrate with a profile diagram. When I ask you to draw profile diagram using catalyst, you have to show me the diagram like this. You draw the profile diagram. You show reaction pathway for the X, reaction pathway. You show me energy, potential energy. You show me the catalyzed pathway, and label it like that. Write this. So write activation complex here. Is activation complex. You can label it full. There you come. Catalyzed activation complex. Catalyzed activation complex. Then you write activation energy. You draw a line. Then write activation energy. EA. When you finish, you do catalyzed activation energy. Activation energy, catalyzed activation energy. Do it for me. Show me all the parts that is needed in the pathway. Okay. What is rate determining step of a chemical reaction? Consider this. Discuss the effect of increased pressure on the rate. Increased pressure. What will happen when you increase pressure on a rate? Who can tell me? We've not talked about pressure, but what will happen when you increase pressure of a rate? Kojo?
Okay. So since pressure is okay, so when you increase the pressure, the increase of pressure is directly proportional to the frequency of collision. So an increase in pressure means a decrease in the volume of the reactant. This will increase the number of collisions, thus increasing effective collision, thereby increasing the rate of the reaction.
Thank you. Increasing pressure means that what you are doing is that you are making sure that you are giving them a small space. Imagine me and all of you, we are in a small room, and then you decrease the room. What a room now you have pressured us into a small part where we can easily collide with each other. That's what we are talking about. That's what pressure does. You pressure us into a small space and you cause us to hit each other. That is very unfair of you to put that into a small volume, a small space, causing us to collide with each other. What is the order of the reaction? Discuss the importance of the order. It helps us to know the for this one. Yes. Someone should give me the rate of reaction for this one. Benita, I called you first, so I didn't mind me. Clinton Rex, give me the rate of reaction for this one.
Okay, so the rate of reaction should be minus dA all on the T.
What?
Minus dA.
Okay. R
of E.
for the reactions rate. Okay. R is equal to minus dA. Okay.
All on the T.
All on the T. Okay.
Should be equal to.
Okay, that's good. But Clinton, take note. He said expression for the reaction rate. So it's equal to minus dB over 2 dt. Is that so?
Yes, sir.
Perfectly. You can be also asked, remember, don't miss reactions rate with rate equation. Or write the rate equation, write the rate law for the chemical equation. Law. The law is different from write the rate expression for the reaction rate. Huh? Okay. Deduce what will happen on the reaction rate when, but there's a problem here. There's a problem. I need to explain this to you well so that you guys don't miss it. I want to find a very clear difference for you in terms of writing it. If they say write an expression, T, expression, write an expression for the reaction rate. I'm looking for the expression. I'm looking for the equation. We are looking for the equation. If I wanted to ask for the A over the T, I'll ask it in a different form. Look at how today my physical class people, I gave them assignment. Let me see. I gave them plenty assignment. Let me check. I asked that question in there. Let me project it so that you guys can see. I gave them a question and I gave a typical sample of how they should ask it. I gave them a question. Look at how I wrote. Okay. See, look at the way I wanted it. Write an expression for the rate of reaction in terms of the reactant. What you see? And one of the product. If I wanted expression for the rate of reaction, in terms of one of the product or in terms of one of the reactants. But when I ask that, let me now share my screen. When I ask that, write an expression for the reaction rate, giving reasons. So that one, we wanted the equation itself. But I didn't say in terms of one of the reactants or one of the products or no. I said expression for the reaction rate or the rate law. Okay, be very careful about this because now deduce what will be the effect on the reaction when concentration of A is doubled and concentration of B is doubled. So I want to solve this one. So let's solve this one together. So write an expression for the reaction rate. So I didn't say in terms of one of the products or one of the reactants, reaction rate. So look at R is equal to K A B squared, right? And what is the reason? The reason for this rate equation is because the reaction is a rate determinant step. So the order of the reactants are equal to the stoichiometric coefficient in the reaction. What I say? It's a rate determinant step, and because of that, the order of the reaction is equal to the stoichiometric coefficient. Everyone agreed to that. Deduce what will be the effect on the reaction when A, concentration of A is doubled. Guys, I want you to see something here very carefully. This part that I've read is very ideal and important. I need you to solve all this for me. Whenever I give you a question that one of the people change, just write the rate law down. So write the rate law down all the time. I'm using one step to explain. So I write the rate law that I have. Let me take my time and do it well. So after writing the rate law down, he said the rate of which one is increased? A. He said A increased by what? When the concentration of A is doubled. Okay. Then I'll come and write the changes that happen. The work they give you. You write it as R1. R1 is equal to K. But the concentration is doubled. When it's doubled, bring 2 there. Then you write your A. Then you bring your B squared. B is not affected in any way because it's A that is squared, all squared. So finally, rewrite it such that it looks like your original one. Finally, rewrite it such that it looks like original one. So R1 is written twice. So first of all, it is rewritten as what the question told you. Secondly, rewrite it in terms of the first one. So let me come and write R1 again. Because multiplication is commutative, the 2 can be anywhere, so it will come out. And K comes out because it does not affect it. So the A comes, then or bracket open. So did you see me write R1 2 times? Okay. I'm giving you a simple way to do it. Only 4 steps. Write your rate. Write R1. The question, what the question told you, write it. And write another R1. Bring whatever you sent inside outside. Bring it outside. Now you can get your rate fair. You see KAB squared has now been written here. R1 is equal to 2 KAB squared. You see? So what can you see there? You can see all this as R. Let me show you. You can see all this as the same as R. You see, it's the same as R here. Can you see that it's the same? So you say that your final answer is, R1 is equal to 2 R2, a 2R. Now from Hano, now Akasa. Or say, when the concentration of A is doubled, the rate of reaction is also doubled. So 2 now ben na matro double, 2 now ben na matro double no. So when it means that when the order of a reaction is 1 and you double it, the rate to double. You triple it, the rate to triple. When the order is 1, that is what we can see from here. When the order is 1 and you double the particular concentration, the rate will also be doubled. Triple, the rate will be tripled. Half, the rate will be halved. Decreased by 4 or a factor of 4, it will also be decreased by a factor of 4. Smart as here. First of all, write your rate. Secondly, wow, so understanding. First of all, write your rate. Secondly, write your thing, that the thing they told you that has happened, and write it in terms of the first one, because it's the same. Come and write it there. You say when the concentration of A is doubled, the rate is also what? Doubled. Can you see that? Can you see that? Some people and most people want to do it like this. When we want to find unity, what do? We divide. When we want to find unity, we divide. So some people today do this. When they write the R, when they write the step and then the second one, they just come and do R1 over R. When you do R1 over R, what you are doing is that you want to bring R1 to unity. It means that you want to bring it to the rate itself. Oh, you are writing it in terms of the rate itself. That's the same thing. So either do mine or just do, when you finish writing the first 2 steps, just do R1 over R. That one to give the same answer as well. So you write is equal to, because you want to bring it to unity. So at then as a son, bring it back to normal. This one too, I brought it back to normal by writing it, bringing the 2 in front and writing it in terms of the first one. So R1 now becomes 2 K A. Then they write B squared. Okay, to book B, that's a book no. On why no R1 over R or persuaded by unity. Guys, you are a masterminder. You are smart. Into unim every step. Men grow. You some people, when you came home, when I told, after telling you that the season is a lazy season, some of you are still sleeping. You see the number of people who join class these days. In here, chinkofu in here. I feel because of that, yesterday I've thought about something. Every weekend I'll give you assignments, strenuous ones. It will help me to see those who are serious. And I'll give you redundant questions. I'll give you questions that will come to your exam. My physical class, I do tests every Friday. Before the NOVDEC elective math, I gave them a Friday test. That's why standard. The question I gave them in elective math to do for statistics was the same question that came in the elective math NOVDEC. So when they came back to school on Monday, they were asking me, hey, say, what do you do? It's called instinct. there, you know what they will ask. Before you sit for a paper, you know all the questions that are coming. Because why they wish they want to was there. Sunny, additional it's so out there. The moment you find yourself suffering to study, there's a big problem. So now let's cancel this. Let's cancel this. And then you have R, and then K cancel K2. Then you have R1 is equal to 2R. The same thing. So if you want to bring it to unity, then you do the division R1 over R. Then you can get your answer. Now if you want to also do it this way, fine. What the bar on here, you can see it, right? Since K A B squared is the same as R, you fix the R there and you get your equation and you talk. If it is clear, say all clear, let's continue. I need 10 people to say time we. So good, guys, good. So see, now what happens to B? What happens to B? So let's talk about B. He said, what will happen when the concentration of B is doubled? So guys, let me show you when B2 is doubled. I don't like dividing. You can also divide. There's no problem. I said it's correct as the one I've done also here. But the one I've done here, I'm using it online because it will give me the answer very quickly so that I can just talk. So reaction of B is what? Is increased. I'm into the same thing. So K comes up. So I write A. Then I write B. But he said B is doubled, right? But let me write the original one first. So write the original one, all squared. Original one, all squared. Then I come and write R1. R1 is equal to is equal to K. You have A. I don't have my mouse with me, that's why I'm suffering with writing like that. Then B is doubled. So when it's doubled, me for 2 mrabont here. What you say? Me 2 number. Number 2 B no all squared. What you say? Now let me write my final R1. R1 now becomes, it's to say 2 number out. But 2 no square now affecting no. 2 no square now affecting no. 2 no square now affecting better than 4. It's meant throw 2, metro 4. Metro 4 abonting. So I write 4 here. 4. Then I write my key. So when I write my key, then I write my A back. I write my A. Then I write my B. Then I write all my the B, the squared is still maintained for B because you know 2B all squared means that 4B squared. So the B squared is maintained, not 4 number bunting. Now I've written it in terms of the first one. Can you see? So I can say R1 is equal to 4R. When the concentration of B is increased by 2, then the rate of reaction is quadrupled, or is doubled by when the concentration of B is doubled, the rate is quadrupled. What does this mean in general? It means that when the order is an order of 2 and you double the concentration, it will quadruple it. When you triple it, it will not apple. Remember number 9, say 339. What does it? So when the order is 2 and you double it, it will quadruple it. Do you guys get what I'm trying to mean? when the order is 2 of a particular concentration and you double that concentration, it will quadruple the rate. When the order is second order and then you triple it, you make it times 3, the concentration times 3, it will become 9 times. I don't know the 9 times, so I'll say 9 po. Don't go around 9 po. I'm just saying that it would make it a multiple of 9. Make it a multiple of 9. Now I want to ask you guys, when I have a third order reaction, make sure you'll be trying the same way. Don't go and search on AI. Look, listen to the understanding. I want to see someone understand what I'm saying. When I have a third order reaction and I double the concentration for that part, what will happen to the rate? Yes, who can tell me? I have a third order and then I double it. What will happen to the rate? Third order. Kojo?
8 times.
8 times. Perfect. I feel much than I say. Now, okay. When I have a second order, and then I halve the concentration. When I have a second order and I halve it, Jeffrey.
So it will decrease by 1/4 times.
Perfect. It will decrease by 1/4. So we call it that the rate will decrease by a factor of 4. I want you to use the chemistry term. The rate will decrease by a factor of 4. The rate will decrease by a factor of 4. The rate will decrease by a factor of 4. Now you guys know the thing. So we're part of the person and say every rate will be a half, say quarter, say then you don't care. Just write your correct rate, just put it inside, just bring it out. When square affected, bring it out. When quadruple 1/4 affected, I said decrease of 4 means 1/4. I can give you a question. I ask you decrease of 4. Decrease by a factor of 8. It means 1/8. Decrease by a factor of 16. It means 1/16. Increase by a factor of 4 means times 4. Increase by a factor of 2 means times 2. Increase by a factor of 3 means times 3. Decrease by a factor of 9 means 1/9. My ejuma we there. It's me chemistry rate no. Come. I'm cleaning the board. Now you people, you should be the best people that understand rates in the world. When it comes to representing rate, showing their magnitude, when it comes to writing rate equation, when it comes to defining proportionality constant, activation energy, activation complex, collision, when it comes to catalyst and all the type of magnesium IV oxide, nickel and platinum, when it comes to everything concerning rate, you should be the best guys in the world. Did you hear what I just said? You should be the best guys in the, no excuse anywhere, because I've taught it to the very core. Okay. So that is it. So now look at a particular question here. This is the last type of question I need to teach you, then I'm done. Look at one question that came. How would the concentration of B be changed in order to halve the reaction? How would you change the concentration of B? So now guys, watch here. We write our rate. Let's write our rate. What should you do to B so that the reaction will be halved? So let's write our rate. Always write your rate first. So our rate was that R is equal to K, the concentration of A, then the concentration of B squared. Then he said we should do something to what? We should do something to B so that the rate we have will be halved. Okay, no problem. That means that it should be like this. R should be equal to half of R1. I said it be as any work now. So like this. So now represent phobia. For R, you have the equation to be this. Okay. Of A. After this one, I've done a good job. Then B squared. It's equal to, then you do half of Then for the R1, you write your A there. But he said you did something to B, which you don't know. K2 comes, K2 comes. You did something to B, guys. You just did something to B, which you don't know what you did to B so that you become half. So let's put X there, then write B, then write all squared. You can divide and check. K will cancel itself because besides they are the same and the equal to sign, you can cancel. A2 will cancel. A will cancel. The half will not cancel anybody. But the B2 will cancel, but X become X squared. So let me write it well. My answer becomes B squared is equal to, in terms of concentration, no, parenthesis doesn't mean that I should remove it. It's equal to X squared and then what? B squared. B cancel itself, okay? So that you can have only one. So it becomes 1 is equal to, because B divided by B is 1, please, half X squared. Half X squared. We need X. We are almost getting X. So we multiply both sides by 2, right? So you have 2 is equal to X squared. I'm done. 2 is equal to more proper board anchor. X squared. So when you are done, then square root of both sides, right? It becomes the square root of 2. What's root 2? Is equal to X.
1.4.
1.1, 1.4, no. 1.404 or 1.707.
1.4.
1.414, right?
1.4. Yeah.
So then it means that you have to multiply the concentration of B by with 1.414 before you can have the rate. How did I do it? I wrote my rate equation. Every time they ask you a question, you write it. Then I wrote what happened. Rate is equal to half of the one that happened. Then the rate itself, I wrote it. Then I wrote the new one. The new one he's talking about is half K A. I don't know what I did to X B, so I wrote X there, all squared. I canceled all the guys that are similar. When I came to B, B2 divide itself to get me 1. I found the value of X squared to show that that is the guy that will cause it to now have that particular change. Do you guys understand what I'm doing? And I found when this. They are not just a home focus here. Me, when I'm teaching, I need high focus because every single dot I say is important and vital for my explanation. So, no understand. Now say me if you me chemistry class, do you hear me saying, do you understand plenty? Chemistry class. I've taken my time so that I make this perfect. So that I don't have any set of confusion. That is why I need you guys to focus. So no confusion. So we are done. So we are done with this part. When I send the file, you go and learn. I'll send the file there now, and I'll give you assignment. Your deadline is before Monday. Sunday. Mobile. Okay, deadline is Monday. Today. And down matching. And a Sunday I'm matching. And a Monday is one matching and Sunday was send it. Like it's good. Into three nights is okay. 3 nights. Until you submit it on Tuesday, okay. Don't worry. Sunday in Kwande ya na edin. That be Sunday wait me you. That question is my man to ebi. Okay. You submit it on Monday. Ansana. Mesole anopa Monday, you know. If I was sleeping in Kwande, let me see your work. What you say? So let me see. Today is Saturday evening. So Sunday, when you go to church and come back, you cook, you do everything. And then Sunday night, you do it. Then you submit it. That's all. It's good. Now, I'm for Sunday, Sunday night, Sunday hold the class for 2 hours. And 5 hours, I can miss you work, mommy. Say no, do bit me. The night is for what? Boiling. The night is for boiling. Well, more boiling. Okay. Tuesday. Final decision. Tuesday. Submit by Tuesday. Before Tuesday morning, submit. That means the deadline is Monday, 11:59. I'll check the work as if my life depends on it. So you have to submit. If nothing motivates you, let someone stress, let the act of someone stressing his own life to let you understand certain things to the core motivate you to do the work. Why? Now I say we too far on serious because obi in your time and I'm won't cast me anytime me name the middle time yana. Huh? Me a computer engineer. I have a work to do for someone. This night I had a meeting with someone at 9. I'm coding a website for him so that he use for his house. He has this houses that he's renting and all that. I could code for him. So I was asking him certification. I had a meeting at him for 9. I friend me 3 times. Meanwhile, I didn't pick up because I was in class with you. When I give you work and you don't do it, you are just insulting me. That's me. I don't know what I use my time for. And all these things will end very soon. So that is it. I've solved it. In case you don't know how to get your work done, I've solved it systematically there for you so that you don't have problems. Okay. All right. So another question here. The rate law is found. The concentration of A is doubled. You can do that. Catalyst is added. When catalyst is added, you know what will happen. It will speed up the rate of reaction, but explain more. The concentration of A is increased by a factor of 2, whereas the concentration of B is decreased by a factor of 4. Did you hear decreased by a factor of 4? Yes, you can tell me what decreased by a factor of 4 means. Yes. Decreased by a factor of 4, what does it mean? Decreased by a factor of 4, what does it mean? Decreased by a factor of 4. Could you just answer?
Meaning it was multiplied by 1/4.
1/4, exactly. Now you are done with that. You are done with that. Now, finally, hey, my bro, let me use 5 minutes to explain this work and let me finish. It means I'm done with rate with you. I'm done with rate with you. I won't teach rate again. And I've done it well. I can use only this table to teach you all the table that will come. Then I'm done. Now, what questions do you have? I want to ask you for inferences. Then I can continue. What questions do you have? What problems do you have? What troubles do you have? Let's communicate some more before I teach you this table. I can use 10 minutes. Then we'll go off at 10:10. Hey, you guys won't talk. And I said, that. All right. Then bye-bye. God willing, Monday or when we can meet again for class. Okay. So bye-bye. Mabre. Hello.
Yeah, very rough.
Mabre do makasa sa. Me ha me hu. Oh, Douglas. The meche no kra moti ase. talk in the chat section. Let me see what is on your mind. Let me read it and see whether I'll do this last section or not. Talk in the chat section. Let me see. Seven people. I get it all understood. So everything is clear. All right. Okay. So with this one, they are just saying that you have to experiment. Okay. Now they want to test your mind on how smart you are when concentration is doubled, concentration is halved. They want to test your mind if you are smart, like from numbers to check the rate equation. You can use your mind to now deduce rate equation. Almost smarter. And I don't know. So they'll give you figures in a table. The table can be shortened to 3. The table can be 5. It can be as many as they want. Okay. So he said from the resultant, determine the overall reaction, order of reaction, and hence write the rate equation for the reaction. So rate equation, write the rate equation. Every time when they are starting, they start with 1. So concentration of 1 and 1. That part is a concentration in your pepe. Come here, pepe, 0.04. I'm teaching you how to inference a table. Then I'll finish. Oh, Melissa. Don't worry. I'll compile the video and post it. This one I'm done with rates, so I'll compel to do that. Okay, so you can watch the video and be fine. Okay. So ahead of next week, I am done with menstruation. I think menstruation left to the only part where I have to do the solid figures. Aside the second, too much ample questions. Then I'm done with polynomials revision. I'll put the polynomial revision on the online tonight. I've compiled the video already. I need to just fit it into it. And I'll compile this one to fit it. Now come menstruation. We are no, I'm a fit here also. So you can go and revise it. Okay. Next week, Monday, I'm going to permutation and combination, and I'm doing it so well that you don't have a problem with it again. That one I can use 2 days to finish. Then you can go on to something else. By the time you go back to school, I've done far more than some people that go and spend 7 hours somewhere. I know, pa. Okay, so the first, whenever you are reading the table, check the table, please. 1.0 and another 1.0 will give us 0.004. Now, when we have the second one, what happened to the equation? When we have the second one, see what happened. The 4 now turned to 0.02. It was decreased by 2. It was halved also when we have the second one. It was also, the result was also halved. Not just an order, no, a 1. When we double it, see what happened. When we double it, it was also doubled. The result was also doubled like the first one. When they were the same, it was doubled. Can you see? 0.008. It's a double of 0.004. So when we double it, the result is also doubled. That means this CL guy has an order of 1. But look at PCL. when we halved it, see 0.5, and here became 1.0. What happened? The 0.004 has become 0.001 unity. That means it decreased by 4, a factor of 4. So when we halved it, it decreased by a factor of 4. Not just a 2 or so. Into the better than half, the better than 1/4. So what I say, and you double on so no, you double on so no. When we doubled it, what happened? Better than 0.016. That means that 2 or so into 2 squared here 4. What you are saying, a 4 back out. So when we double it, you see the result also became double 4 4 16. Sir, in that regard. So we can write our rate law by thinking this way to become CL or power 1. But the PCL is power 2. My Zoom goes off. I'm done explaining this, but come and let me finish finally explain how to use the calculation work to do it. And let's go. Or maybe I can do it some other time. If I come and the number is encouraging, I'll explain, but not, I'll stop. Okay. Yes, you can help me. Should it be always Kojo? What did I just say? The whole class. Hey. Okay, let me teach it because it will be in the video. So someone says, I don't understand. I say, go and watch the video over and over. So could you tell me why? Could you tell me what did I just say?
To find the other unknown part, you need to pick you need to pick 2 experiments which have the same PCL3 or CL2 values in order to cancel one of the variables to get the other. So maybe if you want to get the x, I'll look for 2 equations that has the same CL2 values, which is the 4th and the 5th equation. So I can cancel my y and I'll get my x. If I want to get my x, I'll pick equation 1 and 2 because it has the same concentration values. Then I'll get that one off to get my y.
Exactly. So you say picking experiment 1. So let me I want PCL values to be the same, so I'll find my x, right? So I'll pick. Kojo said he would have picked equation 4 and 5. That is correct. So everyone knows that one. That does not mean I cannot choose equation 1 and equation 4. I can also do that. I can choose equation 1 and 4 because they are also the same. I can still get the same answer. I can also choose equation 1 and equation 5. So far as that side are the same, I just need that. So just choose one of them. So let me choose 4 and 5 like that. So choosing experiment 4 and experiment 5. When I finish this one, I'm done. Okay. Experiment 5. We've never stayed this long here. So I have R is equal to, this is the last part, we are done. Then you put in your values for PCL. The PCL for equation 4 is 0.5. You write equation 4 at the top. So let me write 4 at the top. Then you write the equation for C. C is 1.0. But remember, you have your y at the top. And you have the x at the top here. Then you go and tell them that equation 5. You underline that one too. So you write R is equal to. You have to also write your rate, okay? You have to also write your rate for this side. That one, what is it? For equation 4 is 0.01. So write that one too. So 0.001. Then equation 5 too. You go and pick that one also. We are done. 0.016. 0.016. So Then equation 5, you have 2.0. I said choose either of them. The chemistry book will not tell you, but you can choose either of them. So far as they are the same, you set the other one to the same, then you are gone. So all raised to the power x, y. I need to get a mouse so that writing will be easier. So when you are done, you can now do experiments 4/5. Massa, 4/5 or 5/4, it doesn't matter. 4/5, 5/4, it doesn't matter. Once you know how to do maths, you can do any one over anyone and still get your final answer. So let's do experiment 5. Let me see. I'll do 5/4. You know why I'm choosing that? I'm choosing the bigger one at the top, and the small one will be at the down. So 5/4. That doesn't mean do that all the time. Just choose. One should be up, one should be down. So when I do it like this, let me do it directly from here, all over. You can see this one will cancel this one. Then I'll have 0. This is 4/5. So it becomes 0.016 over 0.001. Then the 2.0 raised to the power x, 2.05 is the power x, right? Then you solve the other section. Let me solve it, Preko. 0.016 all over 0.001. Then you say it's equal to, because the other section has cancelled, you have it like this: 0.5 all over 2.0. Oh no, 2.0 over 0.5, because I changed it. Okay. Hey, are people even listening to me? I fear we've kept long.
Yada.
All over 0.5. Me say one day may cheatathon. Me try there 20 days continuous. No matter how Guinness record. So like this, then you can simplify this. Then I'll simplify this record, this part. Then I'll simplify this part too. Then the power x at the top, I'll have indices. Then I'll compare the numerator, the powers. That's all. I'll compare the powers there. That's all. Okay. That's all. Maybe. What is the rule when you get a table? Charlie, let me tell you the algorithm of table. You can read from the table. If it's half, what was the result? Did it half? Okay, then it's power 1. If it's quadrupled, if it's quadrupled, when I double it, that means it's power 2. You can read. I've taught you this thing too well. If you don't know how to read and you're a lazy person, just write your rate, write x and y at the top. Go and look for the equation that has 2 things the same for a particular one that you are looking for. Set it up. Do one over the other, experiment 1 over the other, experiment 2 over the other, and cancel out. You can get your final answer. In terms of indices will help you get your final answer. Thank you very much for joining in class. I've tried, boy. I've tried. Rate of reaction, chemistry topic cleared. I've done it to the best of my abilities. I didn't leave a single part of it, and I've done well. I doubt anyone will get time to do it that list for you. I doubt. So thank you so much. I'll see you. Let me see those people who are still in class. Akosha Mili, Yvonne, Stephanie, Melissa, Claudia, Besmakidu, Diane, Elom, Frederick. Okay, I'll send chemistry assignment. Do it for me. I'll send chemistry assignment. Do it for me. Rate of reaction. And I'll send a video to. I'm going to share video. Share video no bio. Watch rate of reaction before you go back to school. Go and write rate of reaction in your diary and say that rate of reaction cleared. But make sure you've gone through the site and you've checked through all the assignments, all the notes, all the videos. If you click rate of reaction, you should have all these things there. You have an assignment that is due on Tuesday. I'll check it as if my life depends on it. So go and do it and submit it. I will check it, I'll grade it, I'll give comments, and I'll send the results into the group. Thank you very much. God bless all of you. Ella, pray. Let's go. Ella, please pray.
Shall we pray? Our Lord and Master Jesus, we are grateful unto you that we've had a successful end. We pray that as we are leaving this session, Father, we pray for attentive memory. We pray for in-depth understanding into whatever we've received today. We pray that we are not going back the same, that whatever we've learned here will stick with us and we will do all to your glory. We pray and commit tomorrow into your hands. We pray for traveling mercies as we go to church. We pray and lift up the day into your hands, Father, that you take absolute control of everything that